الو.
ايوه شباب.
طيب
هذا شباب.
والثاني قالوا حق التسجيل. لا حق التسجيل، واحد للجمهور وواحد للتسجيل حق ما ادري والله كان يقول هلنا بالسودان.
الحين احتاج اثنين؟ لا
واحد مو بواحد حق التسجيل. اوكي. شفت اثنين ذيك المحاضرة.
السلام عليكم، صباحكم الله بالخير. أنا أتخيل الآن الخرسانة كيف مبسوطة إنه في كل الناس المهتمين فيها الناس طيبين أمثالكم كذا، ويقولوا والله يجوا الصباح حتى من جد الخرسانة. عرض حسب جدولنا الآن إن شاء الله إحنا ماشيين زي ما إحنا. في دكتور عبد العزيز الغيمش، معلش في الجدول ما مكتوب الاسم بس بالخطأ زي كل شيء تحصل، مثل الكواليتي حقت الكونكريت أحيانا حتى الجداول بننسى أسماء. فالتجربة المحلية في مراقبة جودة مصانع الخرسانة الجاهزة قدمها الأستاذ الدكتور عبد العزيز الغيمش، فليتفضل.
السلام عليكم، صباح الخير. أحسن ما فيها محاضرة الصباح إنه ما في ناس نايمين. الموضوع هذا الكواليتي سكيم اوف ريدي ميكس، يمكن اغلب الاخوان في الرياض يعني مطلعين على التجربه، وسبقوا يعني شافوا عروض عن البرنامج. الناس اللي برا قد تكون المعلومه وصلت والمعلومه او ما وصلت. اليوم في فرصه نحن نستعرض البرنامج قائمة عليه أمانة منطقة الرياض من عام 1415، يعني من حوالي 19-20 سنة. بدأ بمبادرة أنه الناس طلبوا أنه فيه مشكلة في صناعة الخرسانة، أنه فيه غش وفيه عدم الالتزام بالجودة. لذلك كانت في مبادرة وبتوجيه من أمير منطقة الرياض الأمير سلمان الله يحفظه، قامت الأمانة بتطوير البرنامج، واتصلوا فينا الدكتور عبد الرحمن مايسلف في جامعة الملك سعود للعمل معهم كمستشارين. بدأنا بالاستفادة من التجارب العالمية. كانت National Ready Mix Concrete Association اللي هي جمعية منتجي الخرسانة الجاهزة في أمريكا، عندهم عملية اعتماد للمصانع وسيارات النقل. فيه برنامج أكثر تكاملاً في بريطانيا يسمى Quality Scheme for Ready Mix Concrete، اللي راحوا خطوة أخرى في عملية المتابعة، أنهم يأخذون عينات ويقيمون أداء المصانع ومختبرات المصانع، ولا يكتفون بعملية التجهيزات حقت المصانع. لذلك حنا استفدنا من الناشونال ريدي ميكس كونكريت اسوشيشن في التشيك ليست حقت المصانع، واخذنا الابروش حقت الناشونال كيو اس ام ار ام سي في بريطانيا فيما يخص الكونسبت حقت اخذ عينات للتاكد انه الانتاج متوافق، لانه كانت الشكوى هي في الانتاج وليس في التجهيزات. الموضوع قائم عليه الأخوان في الماتيريال ريسيرش ديبارتمنت في تشغيل والصيانة أمانة منطقة الرياض. المهندس سعيد شهراني هالحين متولي عملية الإشراف على المشروع أو البرنامج. كان فيه في البدايات كان المهندس إبراهيم الخراشي الله يذكره بالخير، والمهندس صالح سليمان بعديه، ثم المهندس عود السويدة. لذلك تتابع عليه عدد من المهندسين في الأمانة. البرنامج الحين يعني نفس البرنامج فيه أمل إنه يطبق في بعض المدن الكبرى في السعودية، وفيه يعني فيه خطوات متقدمة في هالاتجاه في أغلب المدن، وفي خطوة باكورد في واحدة من المدن للأسف الشديد. لذلك نتمنى التوفيق للجميع. التركيز هنا على الرياض. نشوف مصانع الخرسانة الجاهزة هذه عام 2011 آخر شيء. تشوف أنه بدأنا عام 1975 كان عندنا مصنعين، وكانت جاية المشاريع كبيرة كجزء من الكونتراكت أو الاتفاقية بين المقاول وشركات أجنبية فتحت فروع لها في السعودية. بعد كذا تطورت العمل. في الثمانينات بدأ يصير العدد كبير، شبكة الطرق صارت تخدم، لأنه ريدي ميكس تحتاج شبكة طرق تقدر توصل للموقع بسلاسة. بعد كذا في 2000 صار فيه اللي دخلوا السوق يبغون الإثراء السريع، طلعوا من السوق. بس في السنوات الأخيرة، في السنتين الأخيرات، الحين هذه 2011، الحين عندنا في الأمانة أكثر من 55 مصنع، يعني زاد حوالي 15 مصنع في خلال سنتين أو 3 سنوات، في قفزة كبيرة. لأنه برضه الحلم بالثراء رجع عاود بعض الناس ودخلوا للصناعة، لأنها ما هي regulated بشكل تام. السكيم استراتيجي من ذاك الوقت كانت انه يصير الزامي، ما هو اختياري، ما هو تقول تعالوا يلي تبغون نراقبكم ونعطيكم شهاده تقدرون تستخدمونها. لا، كانت الاشكاليه من اللور اند حقت الماركت، انه في ناس داخلين الشغله وهم مو اصحابها. لذلك كان الزامي على جميع مصانع الخرسانه، كان اخذ عينات بشكل عشوائي، يعني من الخرسانة ومواد وعملية التقييم، وفي الأخير تقدر تحكم على إنتاج المصنع. كان في قرار ذاك الوقت هل آخذ في المصنع ولا في الموقع، وكان القرار أنه ما تقدر تروح للمواقع لأنك تدخل في إشكالية من المسؤول عن الموقع، هل هو الأمانة ولا صاحب الشان، يعني صاحب المبنى أو المنشأ. لذلك الأمانة قرروا أنهم يأخذون العينات في محيط المصنع، يصيروا مسؤولين عن الجودة إلى ما يطلع من المصنع، ويحطون كتيبات توجيه لصاحب الشان للمحافظة على الجودة في الموقع. احنا عارفين الموقع، الفرق بين المصنع والموقع شغلتين، اللي هي طول الرحلة. إذا كانت الرحلة أكثر من يعني أخذت وقت طويل أكثر من ساعة ممكن تتأثر جودة الخرسانة. الثاني المرتبط بهذا اللي هي مرتبط بالمقاول، اللي هي عملية إضافة الموية للخرسانة في الموقع، ليس بالطريقة المقننة حقت ASTM، إنما بالطريقة العشوائية اللي قاعدة تتم وما زالت تتم في أغلب المدن ومنها الرياض. النقطة جوهرية صراحة لنجاح أي شيء، إنه التدرج، حكاية إنك توصل اوكي، من الرياض الى جده في ساعتين مستحيله. اوكي، لذلك لازم يكون عندك الايش النفس الطويل، وتقبل انه كل شيء ياخذ ايش وقته. لذلك مشينا بالتدرج، وحنشوف المراحل اللي مر فيها البرنامج. اهداف البرنامج كان يعني تركيز على الجوده، بس حتى تحصل الجوده لازم يكون فيه upgrade of plant equipment and facility. اوكي، كانت في شغله ذاك الوقت، كانت شغله المصانع او المصانع الزينه على الاقل، يقولون السوق فيه غش. اوكي، في ناس قاعدين يغشوا المواطنين ولا حد داري. اوكي، وهذول ذابحين السوق، ذابحين الاسعار. اوكي، لذلك فعلا ركزنا في البدايه على عمليه التنظيف من الايش الغش الواضح. اوكي، ما هو والله انه ما هو قادر، عنده مشكله في ضبط الجوده، انما ايش يحاول يوفر في الاسمنت بدون وجه حق. لذلك كانت documenting and exposing cases of intentional cheating كانت في كم مصنع أغلقوا في ذيك المرحلة لأنها كانت ثابتة عليهم العملية. كانت الإشكالية أنه في البعض يسوي مصنع ويأجره من الباطن، لذلك اللي مستأجر من الباطن يبغى إيش؟ يبغى يعني في بعضهم قاعد يفكر في الفلوس، ما يفكر في لا سمعة المصنع ولا يحزنون. Evaluating the competence and effectiveness of the QC staff in each plant. وكان هذه مرحلة تركيز، بس الأدوات عملية أنك تتحقق من الكومبتنس ما زال عندنا إشكالية فيها في البلد. أوكي، يعني إحنا بدأنا في الACI الأمريكان كونكريت انستيتيوت الشابتر السعودي شابتر في عملية certification of technician. أوكي، للأسف الشديد النمبر of certified technician ما هو عدد كبير، يعني في عدد طيب certified بس تلقاهم من ايش؟ من شركات ومختبرات محدودة. Activate and improve in-house quality control practice and program. ذاك الوقت كان حوالي ثلث المصانع حتى المختبر ما هو موجود عندهم. اوكي، هو يقول عندي ريسبي، عنده طبخة ماخذها من جاره، المصنع الزين اللي يشوف عليه إقبال. أوكي، وبعضهم حتى بعد مستخدمين نفس الاسم، بدل ما هو شركة حاطين مسمين مؤسسة. أوكي، للإيهام إنه إيش؟ إنه المصنع هو إيش؟ هو المصنع المشهور. هذه حلت، حنشوفها بعدين. Developing a database about RMC industry in Riyadh to help develop local specification for ready-mix concrete. يعني أنا واقف قدامكم قبل أمس. أوكي، من واقع الخبرة اللي اكتسبناها في هالبرنامج من خلال التعامل مع المصانع. الحين صاروا المصانع نعرفهم أكثر من نعرف عيالنا من خلال الإيش؟ برامج المتابعة وأخذ العينات وعملية التقييم السنوي اللي احنا نسويه. هذه هي الكلاسيفيكيشن اوف ريدي ميكس كونكريت بلانت. هذا ما سويناها في المرحلة الأولى، سويناها في مرحلة لاحقة وما زالت مستمرة، وهذه تعطي المصنع وتعطي everybody اليوزر تقييم. يعني إذا كان من مصانع فئة ألف فهو من المصانع اللي ممكن ينافس حتى في أي دولة أخرى، يعني منضبط، عنده السيستم، محافظ على الجودة، عنده التكنيكال نو هاو. أوكي، بس ما نتوقع في بيئتنا إنه كلهم بيصيرون فئة ألف. لذلك فيها فئة باء جيد وفئة جيم مقبول. المقبول بكل تأكيد أحسن بكثير من الالترناتيف اللي وراناها الدكتور عبد الرحمن، اللي هو الخلط في الموقع. الخلط في الموقع شفنا القوة كانت ممكن بعد تصير تحت 10 ميجا باسكال. على الأقل المصانع ملتزمين أوكي بال30 ميجا، حتى إذا كان في قصور إنه ما بعض الأحيان ما يجيب ال30، بس يعني حالات معدودة اللي إيش حتنزل عن 25 وال20 ميجا باسكال. بس برضه أوكي يعني اللي عنده إشكالية جودة البرنامج يتخذ إجراءات ضده تصل إلى حد الإغلاق المؤقت في البداية والإغلاق النهائي إذا ما تحسن الوضع. Educating RMC producer and the public about the quality of ready mix، وهذه ساهمنا فيها من خلال البرنامج، من خلال المشاركة في ورش عمل، من محاضرات عامة. يعني الأمس شفنا عملية الأهمية حقت التستنج وضبط التستنج، أوكي، عملية الكاليبريشن حقت التستنج ماشين، أهمية الانترلابوراتوري لاب interlaboratories program to establish reliability حقت التستنج حقك، أوكي، أهمية الأجواء الحارة على جودة الخرسانة. كلها إيش من المواضيع المهمة. البابليك كانت فيه كتيبات مبسطة لضبط الجودة في الموقع، وهذه نقول له يعني احرص على أساس أنك تأخذ، ما تروح تأخذ لي من مصنع بعيد، ركز على المصانع القريبة. لذلك يعني تعليمات مبسطة أكيد أنها تساعد في عملية الارتقاء بالجودة. والسكيم هو منظومة، أوكي، بكل تأكيد. يعني عندك الانسبكشن اند سيرفيلنس بروجرام اللي هي عملية الزيارات العشوائية للمصانع، وهذه تتم من أجل عينات الخرسانة مرتين بالمعدل، قد تكون من مرة إلى 3 مرات في الشهر، أوكي. وعملية زيارة evaluation سنوية لكل الفاسيلتي في المصنع، أوكي. فيها سكيم internal quality assurance program، هذا تتم بين الجامعة وبين الأمانة للتحقق أنه والله القياسات حقتنا وعملية السامبلينج اللي نسويه في الأمانة، أوكي، reliable، حتى بس ما حد يشتكي أنه والله إيش إن عندكم مشكلة يا جماعة الخير وقاعدين تقيسون الأداء حقنا بمسطرة ما هي صحيحة أو أداة ما هي صحيحة. فيه administrative and follow up activities، هذا اللي تقوم بها الإخوان في الأمانة، وهذه عملية متابعة المصانع اللي عندها قصور، أوكي. technical support and development، هذا يعني الجزئية اللي أنا والدكتور عبد الرحمن يشارك فيها بشكل جوهري. public awareness program، هذه من الأنشطة اللي برضه هالمحاضرة جزء منها. هذه تفصيل أكثر لسكيم inspection and surveillance program. نشوف إنه فيه plant inspection and evaluation، ويغطي site organization, material storage and handling, batching equipment and method, truck mixer and agitator, laboratory and QC practice, hot weather precaution and ticketing system. هذه similar، شفتها في ASTM، شفتها في National Ready Mix Concrete Association، شفتها في الجولف ستاندر اللي تكلمنا عنها. هي يعني متطلبات أي محطة خلط هي إيش مغطاة بالمتطلبات هذه. في Mix Validation and Approval، هذه الخلطة احنا ما نعطي المصانع خلطة، المصنع هو اللي يقدم خلطة للأمانة، وفي التعليمات انه والله لازم يكون في خلطات معينة، على الأقل 3 أو 4 خلطات تغطي السبستراكشر، الأجزاء المدفونة، وهذه لها متطلبات أكثر تشدد من السوبر ستراكشر اللي هي يدخل فيها البلاطات. الأعمدة لأهمية الموضوع حطيناها جريد أعلى شوي، يعني هذاك السبستراكشر حطيناها C35 كيوب، أوكي. السوبر ستراكشر ممكن يصير C30 إذا كان التصميم الإنشائي يسمح بC30، إذا كان التصميم الإنشائي يتطلب أكثر من C30 أكيد تمشي على الإيش التصميم الإنشائي. البلاطات قلنا C30، الأعمدة C35، أوكي، لأن إحنا لقينا فيها قصور كبير، لذلك تبغى تصير عندك إيش يعني احتياط، أوكي. وفيه صبة النظافة هذه اللي هي C20. بس اللي يقدم الخلطة هو الإيش المصنع، وعادة نطلب منه أنه يكون متوافقة مع ال ACI 211 أوكي، اللي هي عملية proportioning of concrete أوكي، وتكون المواد محققة لمتطلبات المواد C33 أوكي. يعني ما كان عندنا مشكلة إنه المصانع يحققون هالمتطلبات. يبقى عاد عملية البروبورشن حقة الميكس كانت فيها أول الكل يشتغل بالسمنت كونتنت 7 أكياس. هذه هي الإيش 7 أكياس يعني 350 كيلو جرام للمتر مكعب. كانت هذه الخلطة الإيش الدارجة أوكي. كانت في بعض المصانع يشتغلون على السترينث، عدد محدود من المصانع قاعدين يشتغلون على السترينث. في الأول قلنا أوكي نمشي على 7 أكياس ما عندنا مشكلة، بس لازم تحققوا لنا حد أدنى من الإيش من القوة، وكانت ذاك الوقت 30 ميجا باسكال أوكي. مع الوقت طورناها وحطيناها خلطتين C35 وC30 وقلنا إيش إنه في حد أدنى من كمية الإسمنت، ليس 7 أكياس إنما 330 أقل شوي، 6 أكياس وتقريبا ونص أوكي. بس لازم تحقق متطلبات السترينث. يعني بعض المصانع وعدد من المحدود من المصانع ممكن يحقق السي 30 اوكي ب 330، بس اغلب المصانع من تجربه هالسنين الطويله اوكي اذا حاول يقلد هذول يفشل. لذلك احنا نعطيه الفرصه انه يثبت انه قادر من خلال اعتماد الخلطه اللي يتم على بشكل سنوي اوكي بالمواد اللي هو يستخدمها. احنا نسحب عينات من المواد من عنده ونسوي خلطه هو يسوي اكيد الميكس ديزاين، هو يعطيناه لعمليه الفاليديشن. احنا بس نتاكد انه والله محقق الخصائص ما يخص السترينث، ما يخص الهبوط او الوركابيلتي اوكي، والوركابيلتي ريتنشن انه عمليه يحافظ على الايش، وانه الادمكشر دوزج في حدود الايش الريكومندد دوزج من المانيفاكتشرر. لذلك this is يعني providing uniformity في الشغله هذه. بس مع ذلك اوكي البعض يعتقد انه ما زال يطل على جاره اذا كان يستخدم 330 وهو يحاول يسوي 330، ثم تبين معانا من خلال العينات العشوائيه اللي ناخذها بشكل دوري قلنا on average مرتين في السنه. اوكي so هذه surveillance activities random sampling and testing of material اوكي. سمنت ما كان عندنا مشكله، بس انه خلال السنين نعرف انه بعض الاحيان يصير عندنا ايش مشكله اسمنت اوكي. سو في عمليه السيرفيلانس وي دونت تيست سمنت بيكوز ات از ذا سورس محدود الى مصنع او مصنعين في الرياض. نروح لعمليه المراحل اللي تمت فيها النظام للاخوان في البلديات الاخرى اوكي. كان مرحلتين 3 مراحل. المرحلة الأولى كانت لمدة حوالي 3 سنوات، وكانت introduction of the scheme requirement, monitoring of RMC plant production و database for ready mix in رياض. عام 1999 2000 بدأنا في عملية عملية التصنيف كأداة their testing and testing frequency okay. Also we look at concrete test and cube curing and testing, documentation of lab register and report to see compliance. We evaluate and we give our evaluation to the plant before we make it official. So the plant, if our evaluation does not reflect to him, from his opinion, what is existing in the laboratory, okay, or in the plant as a whole, okay, he can come and raise issue with that, and it should be clear before we make it the classification official. There is the most important item which is showing a variation between the plant is this production quality indicator, okay. So it is based on test on concrete sample collected randomly from each ready-mix concrete plant at the rate of 1 to 3 sample per month, okay. So control of temperature, we give it 25% control, and control of temperature is that at the batching plant he can meet the 32 limit at the batching plant. This means that when he comes to reach the site, he should not have a problem meeting the 35 temperature limit, which is specified now by the code. Okay. Workability of concrete mixes also, as you know, concrete will lose workability, so you cannot start from the batching plant at 100 millimeter mix, okay, because when you reach at the site, okay, you are going to lose some of that during trip time or travel time. And the travel time, here we estimate that from actual measurement, okay, from feedback of the ready-mix concrete supplier, that we have around 50 to 1 hour, okay. So if you look at the slum loss, it is around 40% of your initial, 30 to 40% depending on the season, okay. So this is, when we do the validation test, it should be above 150 millimeter to allow for the loss of slum during transit. And this is creating also issue with the spillage of concrete, because it is too fluid, especially if the truck is loaded above capacity. So it is a challenge. Workability of concrete mixes, 25%. Compressive strength test result. And here we are using cube, okay, and we decided to use cube. At that time, cube was the predominant. Only big projects use cylinder. So most concrete suppliers don't know how to test cube, but few of them know how to test cylinder or have the facility to test cylinder. So we said, well, we are going to go along with you guys. We'll use cube, and cube has the advantage that you don't need to have cabbing, which is, important. Also important, proper cabbing is important for the integrity of the cylinder testing. Level of production control, okay, and this is the variability, the standard deviation from our data. But in the last few years, we also take data from the batching plant, and it is interesting, and this is need another lecture, that somebody will claim that he can produce concrete with a standard deviation of 1 megapascal. Okay. When we see 1 megapascal, we lose confidence in the QC activity and the gentleman who is in charge of that. Okay. Sometimes you have 2.5. Okay. Our experience is that it is even the better one. Sometimes can get 2.5 to 3. That's possible. Okay. But anything below 2 and anything above 5, okay, mean that we have a problem. Okay. So we go and witness the testing to verify that his testing is proper, and to educate him, to educate the people in there that if you don't like the test result, whether it is high or low, don't throw it away. It is part of the value of testing. Okay. The variability, you can only assess it if you respect what you are getting, not if you only respect what you like. Well, this is the classification, and we said that we have 3 criteria, and there is the rule, okay, how much score in each of them, okay. And then we classify the plant to 3 categories. Class A can compete with international ready-mix concrete plant anywhere, okay. We have Class B, who is trying, but he has some problems. Sometimes it is not with the quality of production, but rather with the facility. He doesn't have fully automatic, or he doesn't have ISO certification, so he cannot get a Class A. He is getting Class B, okay? Or he's an average producer, and he is not looking to improve to Class A. We have Class C, which is acceptable, and sometimes we say it is not acceptable, but thinking about the alternative, which is site mixing, we think that still this is providing some alternative or better than site mixing. This is the rule. You can see that we are for the plant and facility indicator, okay, we are asking for 80% score, okay? For the laboratory and QC activity, 80%. For the production quality indicator, we should have 85%. But also he has to meet ISO certification, ISO 9000 certification, and he has to have a permanent recorder in the batching plant to record the material going into the mix, and he can provide this data upon request. So these are the requirements to get a Class A. If he is not meeting any of this requirement and meeting the requirement of Class B, he is a Class B, which is, the limit is 70% for the indicators, okay? 60%, okay, is for Class C, and if he does not meet that, he is not classified, and he will be under more scrutiny by the scheme. Well, this is an evaluation sheet, and this evaluation sheet is given, as we mentioned, as part of the annual report, classification report, and we give it to the batching plant before we issue the classification and make it official, okay? So this classification, he can challenge what the score he got. He can come and ask, no, this is not correct, because he has the data. Even the data of the random sample, the monthly random sample that we take, there is a monthly report which is given to the batching plant, okay? So he knows, okay, right away his score. He can calculate his score ahead of us, okay? So there is no issue with the transparency. Everybody has this chance. This is, you can see that in the production quality, he's not getting 85. Otherwise, in the other indicator, he's getting 80, which is the requirement. He's qualified to A. He did not get above 85 in the quality indicator, so he is a Class B. Well, in the improvement in the optional, we can see this is the classification. This is incentive. We did not impose it. They chose to do it, okay? You can see that sprinkling of course aggregate jumped from 10% to 88% because he gets a score for it, okay? Ice plant jumped from 7% to 46%. We don't impose it. It is optional. But they chose to do it to control temperature on one hand, and also to get the score, okay, which is allocated to ice plant. Improvement in the batching plant. I had this lecture a few years back, and when somebody saw this number, and I was saying that this is because of the scheme, he said, no, it's not only because of the scheme. It is because the technology evolution, okay, with time, okay, nobody will manufacture manual or semi-manual. It is automatic, and he has a point, okay? But things are, you can see the development, and we are through the classification, okay, and pushing into that direction, that the batching plant has incentive to upgrade his facility. And if he upgrade his facility or buy a new batching plant, most likely it will be fully automatic batching plant. But he is not forced to do it, okay? Well, this is the classification. This is 2010, okay? And we reach our best performance at that time. 40% of the batching plant in Riyadh at that time were Class A, and the other 40 or 44% Class B, and 10% Class or 60% Class C or not classified. Of course, during the last 3 years, okay, the number did not change, but the percentage reduced because the number has changed, okay? Concluding remark, if you allow me, okay? The quality scheme had a positive impact on ready-mix concrete. This is our colleague in other part of the kingdom, okay? And in other Gulf state. The quality scheme had a positive impact on ready-mix concrete industry, resulting in a substantial upgrade in the facility of ready-mix concrete and their ability to produce good quality concrete under adverse hot weather condition. Classification of RMC has proven to be a very effective tool in speeding up the positive impact of the quality scheme. The 3 indicators developed for the classification scheme provide a scientific basis for monitoring the overall improvement in the various aspects of plant operation. The experience of the quality scheme for ready-mix concrete implemented by the municipality of Riyadh over the past 15 years, now it is almost 19 years, show that such system can succeed in developing country despite all difficulty and challenges. And thank you very much, and thank you for allowing me to reach this point. We need microphone.
Thank you for this, what you said, but I'm asking about environment. Because you said he should take ISO, maybe ISO 9001, or will it say ISO 14001 or 18001? Is this any direction that you will take care about the 14,001, because this is very important in Riyadh, I thought, because this is
I think you have a point. I think before it was only the management system 9,000, but I think the safety and the impact and the environment should be emphasized for at least for Class A.
This is not mandatory. This is non-mandatory, I thought.
No, but for Class A they should pay, and I think they are, some of them already have it. Okay.
9,001 or 14,000?
No, all of them. Class A, all of them now have 9,000. Okay. It is mandatory to be Class A according to the scheme requirement. Okay. I'm talking about the 14 and the. Okay. So it is a good point.
Thank you.
Further.
Doctor, have you considered about this ISO health and safety certification on the ready-mix plants?
Yeah, this is now the issue we're talking about. I think this is probably should be part. Now it is not, okay? But I think it is worthwhile to go to that.
Do you think it is going to be implemented in the near future, or
we'll see. I mean, sometimes you need also to think about your capability of implementation. I mean, you ask for something, you should be able to follow it up, but it is very important.
because when the drivers reach to the project sites, they have two options: either follow the quality control precautions on the site, but if it is not there, not every site has a good quality control program. Then they will be like randomly moving around and, exposed to many dangers here and there.
No.
And I think each ready-mix plant should have some sort of ISO certification to protect their people at sites, right?
I think it is a valid point, yes.
Okay, thank you.
And now we are biased toward this side.
Good morning, Doctor. What about now the other patching plant run by the company itself? For example, we have this, the precast industry. They have their own patching plant. Okay, is there any control on that patching plant? This is number one. Number two. Now there is a new technology in developing the patching plant. Now in Europe and USA, our friend Richard knows, they are now using what we call vertical patching plant. Vertical, not horizontal. I mean, the aggregate will be stored on the same tower. Is there any rule to force the people who are getting only money? I'm sure the people of ready-mix, they are caring about only money collection, not quality. But if you force them to do some technique, which is, as our friend said, environment protection, quality control. Thank you, Doctor.
I think the first point, which has to do with the precast industry. I think the precast industry is not covered by the scheme. Okay, but it is. I think from our experience, me and Dr. Abdurrahman, we had a chance to work on the mega project of King Saud University about it is as a quality representative of the owner. It is a 12 to 13 billion real projects, including the new girls campus, the endowment project, and the medical complex, and housing, okay? We feel now strongly that even they are much better than ready-mix concrete supplier, but still a quality scheme for the precast industry is required, okay? On the other point, I think your point is well taken, okay? That those أبسميهم الأدعية على الصناعة, okay? Those who are not supposed to be in the industry, if you put more stringent requirement and safety and environment is not an option. It is mandatory. If you put these, because they are meeting the quality issue, okay? They have no problem with that for the most part, okay? But if you put the other one, some of them will be reluctant to enter this market because it will require from them more investment than they are willing to put. But your point is well taken.
شكرا دكتور عبد العزيز. حقيقة نحن أخذنا 10 دقائق إضافية لأنه yesterday Richard took 10 minutes from Dr. Abdul Aziz, so today he is giving him back. So it is okay. The next presentation is Plan Certification and Accreditation Processes, عمليات وإجراءات اعتماد المصانع وإصدار الشهادات. طبعا الجزء الأول والجزء الثاني هو فقط من ناحية الوقت، يعني اللي هي نفس العملية مستمرة، بس لأن حناخذ بريك بعد كذا فسميناها في بارت 1 بارت 2، بس هي محاضرة واحدة مستمرة. So Dr. Richard, welcome.
I may have to stand up here because I can't get the microphone to clip. So, good morning. Salam. I've got to remember that. I've been practicing. I'm going to finish exactly at 10:15, right in time for the break, and then we will start again at 10:30. And I'll go right to 11:30 for the next speaker. I won't take his time. We haven't worked out that arrangement yet. I'm going to talk about this morning, if there's somebody who could come fix this, that would be helpful. Oh, is there another one? Oh, perfect. Is this working? Better? Oh, much better. Thank you. Shukran. I'm going to talk about plant certifications, but I'm going to talk about them in two categories. The first is an ordinary plant certification and quality management system, and then I'm eventually going to finish up today and talk about certifying plants that are sustainable. We're going to talk about sustainability towards the end of my presentation with plant certification, and then my final presentation of the day and of the conference is going to be about sustainability. So it's kind of a natural progression and lead in there. As I go through the presentation today, you'll notice the slide has changed. You'll notice the NRMCA here and the NRMCA here. The NRMCA, the National Ready Mix Concrete Association, is responsible for establishing and developing this plant certification program and this management system. Now, here's the programs I'm going to talk about today. very similar to what you just heard a presentation on. And then I'm going to talk about this one here. This was a natural progression of what was happening in the industry. Not just did people want plants certified for quality, they wanted them certified to have the lowest environmental impact in the communities in which they were operating. When we opened this conference, there was a statement made about the users, the safety, the quality of the concrete we were producing, and the impact it has on the communities, the users of it. Most of them don't even know they're using it. The people who drive down the roads, the people who live in the buildings, the people who work in the communities around the plants and the factories. We have now looked at that and said we want to say how green, what is the lowest environmental impact one of these plants can have, and how do we certify a plant for that? Now, this is a statistic about, and I was, the improvement that you have made since 1995 here is amazing. It is significant, and it should not be taken lightly. That is an enormous accomplishment. We have had, we've had to go all the way back to 1966. But the leaps that you have made here since 1995 are amazing. These results here just are really more about time than anything else. We did not have a significant curve like you've had here. Ours was much flatter through growth. But I'm going to get to the key part of why this is so important, not just from a quality standpoint, but here's what drove it more than anything else, is this group right here. It was required. It was required. If you wanted to sell concrete to one of these groups, they required the plant certification. Now, the interesting part about this was it also meant you could be in business and not sell to them. If you chose not to be under this scheme, you could choose that. You did not have to conform, but if you wanted to sell concrete to these groups, you had to have the certification. Now, other projects also included it. High-rise construction, big commercial projects, transit systems. They understood the value of this quality that these certifications were providing, so they required it in their specifications. Yes, sir.
How is the ACI 301 approved?
Okay. His question was, what about ACI 301? So ACI 301, as part of that, has an item in there that says you will have a plant that will supply according to this certification.
Yeah, but I mean, how you are making them as a group?
Oh,
If you don't comply,
you cannot yeah. So ACI 301 had it as part of its specification, its code, as part of there. But what ACI 301 did was, so as not to support one commercial entity over another, what they said was, thou shalt be NRMCA plant certified or equivalent. Or equivalent. So, because NRMCA is a commercial enterprise, even though they're a national trade association, they make money from charging to do this. They put in a phrase there, or equivalent. And I'll give you a great example. So, I have a ready-mix factory, but I am a licensed professional engineer. I come up with my own scheme that matches some of those exact same things. I measure, test, provide results, and sign and certify. That's an equivalent to that. Does that make sense? Okay. So, the other thing is the plant certification. This is a little bit of a difference from the one you just saw. The plant certification does not address the quality of the concrete. It addresses the quality of the factory to produce the concrete. A little bit of a difference there. Doesn't address the quality of the concrete, it addresses the quality of the factory to produce the concrete. Now, This is a very similar to the graph that was just shown about the growth. Here is the number of NRMCA certified plants, about 2,500 now. These are the states. I'm going to show you, because there's some right here in the kingdom that are certified under this system. This is the NRMCA plant certification, and it actually has audits of certain things. You'll see the first one listed there, ASTM C94. The other one you'll see here is AASHTO 157. It's another one of those schemes. As I've been listening the last several days, I've heard about ISO, European standards, local standards, ASTM standards, and we can list and list and list those standards. We have some of those same issues, and so we have concrete that has to conform to other groups, and one of them is AASHTO and a couple of these other groups here. Now, this is the big one. Required by specifications. When it's in a specification, it's what we call a hard specification. It's required. You must have plant certification. Now, the part about that that becomes the challenge is when a job goes out to bid, somebody reads in there, a salesperson reads that, and they say, we want to supply concrete to that. Oh, I have to be a certified factory or a certified plant. Oh, just call somebody on the phone. It doesn't happen that way. You have to know that you have to do this ahead of time. And so what this did was it didn't force anyone, but it made certain companies who wanted to compete think ahead and say, I'm going to get my certification and my qualifications ahead of time, so when the next job that comes up that requires it, I have it. And I just pull it out of my, and here it is. And now all of a sudden, from a competition standpoint, instead of having this many competitors, I had this many competitors. Now, anybody who is in an environment, much like I've heard that goes on here, where it's very competitive, you want to figure out how to change that environment, and this was one of the ways it happened. It wasn't by intention, it was by default. What I mean was the companies who chose to do it found themselves in a better financial and a better competitive position. Now, here are these sections, very similar to the scheme that you just saw, material handling, batching, central mixing, ticketing systems. But here was the one difference that I noted was on number 5, and I'm going to get to that one here in a second, was on the delivery fleet. Because we consider not just the factory and the plant, because we do a lot of dry batching, not just central mixing, we do a lot of dry batching. We consider the trucks as part of the quality system. So I want to show that a little bit more. Now, by history, I also have served as a plant inspector. I'm a registered plant inspector for the NRMCA. Just to perform the inspections, you have to take an exam. So I'll show that in a second. So here is the certification of conformance that you would have for your plant in the state. The other thing is I highlight for you here. Not just does the company official sign it, but we ask for the highest ranking official to sign that document for the company. The president of the company signs and says, my plant has been certified under this scheme. Not just a quality control manager, not just a technician, but the president. Plant Inspector's Guide. I had told you that I was a plant inspector, registered. There's actually a guide to know how to perform the inspection. I had to take it, the first year they did this, you just read the inspection and you just performed it. The second year, they made you take an exam on it, and then you had to have your card in your pocket when you went to perform the inspection. So, they also have this here. Find a certified plant. This was the other thing that was very important. Was just because you have a certified plant, well, what if I'm a contractor? What if I want to buy concrete? This is part of the marketing aspect. I can go to this website right now, and I can click on it, and I can find every plant that is certified in a region. And let's say that I wanted to pick one here for Saudi Arabia, the kingdom here. These are plants right now today that are certified under this scheme, and all I had to do was go right online, do a search, and the plants come up. Very simple, very effective, very easy to do. Because here's the other thing that this did. This prevented someone from falsifying a document. This is the closed loop. Oh, I have a certification here. Well, how do I know that that's a valid one? I went to the organization that issues them, and I'm listed here online. I could validate that document very quickly, very easily to prevent fraud. And here is also, would you like to get your plant inspected? Go right online. This is a listing of inspectors that are capable of performing that right here in the kingdom. I know that it's difficult to read back there, but there are certified inspectors in Doha, Dubai, Abu Dhabi, Beirut, that all can perform those inspections here or in those countries. So again, online, the openness and the transparency of how these certificates can be obtained was another key part of this. Oh, the other thing was, I became a plant inspector. I told you that. Guess whose plants were the first ones I inspected? They were my own. Absolutely. There was nothing in there that prevented me from being a certified inspector because I took the exam, I had the qualifications. I was able to certify and inspect my own plants and then provide the certification, provide the documentation. So there was actually an incentive for our company to have me do this. Yeah. The interesting part was, what happened when a competitor called me and said, hey, can you come certify my plant? Okay, so materials storage and handling. Again, very similar to the scheme that was just presented. But I'm going to go into a little bit more detail on that so you can understand how far we pursue the certification. So the first was on the types of scales, and particularly the accuracy. So this went actually through the range of use on the accuracy of the scales. Have any of you ever seen how they actually perform scale calibration? How they perform scale calibration? They load it, they test it. They load it some more, they test it. They load it, they test it, all the way through the range of that. It's exactly the same thing that has to happen here. Now, did I actually do that as an inspector? No, I did not. Third-party company comes in and does that under the supervision of the inspector. Because I don't have, nor do most inspectors have the expertise to actually do this. You have to have a scale calibration company come in and do this. We also looked at it in two ways. We took into account two different types of plants. The first was those that use weigh batchers, those that measure the material by mass. The other one was those that do it volumetrically, that measure the material by volume. There were still plants, we still have plants in existence that do that. So we had to have both of those there. The other one, and this was probably one of the most difficult things for plants to deal with when it comes to accuracy from a batching standpoint, is the moisture meters. Is the moisture meters in the sand silos or the sand bins. Now, we don't have moisture meters in the aggregate, coarse aggregate, but we do have them in the sand. Making sure those were accurate, it's the number one thing that I would use the word ding. I would cross them off. I would give them a negative I would take points away when in their moisture meters, because those things never worked. They just weren't working. Well, if you go do a plant inspection and you didn't have a moisture meter that was working, that hurt you in your plant inspection, and in many cases you could not pass if you didn't have a working moisture meter. So we had to check that. Everybody know how you check a moisture meter? You look at what the moisture meter tells you is that, and then you have to do an aggregate moisture cook-off. You actually have to go take the aggregate, weigh it, put it in an oven, weigh it again, calculate the difference that's moisture, and then measure that against the one that you had from the silo. Now, big graphic here, but notice 1%, plus or minus 2%, plus or minus 1%, plus or minus 3%. What do all of those look like and match up to? Exactly what you saw on ASTM C94 from a tolerance standpoint, exactly what ACI has from a tolerance standpoint. These weren't just numbers that were grabbed randomly. These were numbers that were specifically chosen based on existing standards. Yeah, here, water, weight, or volume, 1.5% of desired quality, plus or minus 1 gallon. It's plus or minus 1% on weight. So there's a little bit of a difference there. The other thing here is on admixtures. You'll notice here plus or minus 3% of desired quantity. That matches up as well to ASTM. So, batching control systems. Now, interestingly, I thought there was I noticed another difference as I was listening to the earlier presentation was combination of all batching controls. This system will still evaluate and give credit for manual systems. You can still run a manual system as long as it meets the requirements. Now, just like I thought there was a slide in the last presentation that was fascinating to me because literally in that short time period, the percentages switched from about 19% to 70% to 70% to 19% in that time period. That was extraordinary. Those are extraordinary results. We still have people that are operating manual systems way, way far out in the country, but because when they get that far out, they're supplying usually government work, big projects, road projects, isolated projects, and so the requirement for the government was they had to be certified, so we still had to be able to allow that in the system. Okay, recorders. Properly protected without the ability to tamper. This was the other thing, preventing fraud from occurring. Just like it was mentioned in the last presentation a couple of times about cheating, theft, and fraud, we have the same concerns, but we want to actually include that in there, and so we want to minimize the possibility to do that, and this was one of the big issues. You can't tamper with it. Once the document got printed, there was a record of it. It existed. It was in triplicate. How did we get copies of that? You couldn't change it, those kind of things. Central mixing option, this was the other thing. Notice here, capable of producing uniform concrete. This is under C94. The time to do that, we linked it back to one of the production documents, ASTM C94. And then finally here, equipped with a timing device that will not permit discharge before the mixing time has elapsed. So, if the mixing time is 2 minutes, you could not discharge before the 2 minutes was complete. You could not, we want to move faster today. We want to increase the production. We had to make sure that it said if you were going to mix for this amount of time, you had to mix for that amount of time. Again, no cheating. Mixing uniformity. This is nothing different than doesn't exist already in the ASTM C94 document about uniformity. There's an entire appendix in the back of that. This is how this specification conforms to that. The other thing here was the coarse aggregate. That was a little bit different because that's not in the uniformity aspect of C94, but you actually have to do a rinse here and make sure that you are not losing aggregate. ASTM C94, I talked about this 2 days ago, or maybe yesterday, about the batch ticket requirements shall include. That's not a polite suggestion. It's a mandatory requirement. The batch ticket shall include, so we had to verify, what does your batch ticket look like, and does it have all of this information? This, of course, was the optional here, but this was the big one. Did it have this? Now, I want to spend a little bit of time on the delivery fleet because we spent a lot of time here. Just because you were central mixing or dry batching into the back of the truck was the main transportation unit, and it was the last thing to touch the concrete before it arrived at the purchasers. It was the last thing to touch the concrete, therefore it was the last thing to impact the quality. So we had to take into account the delivery fleet. The other thing was 90% of your delivery fleet. So if you had 10 trucks, that means 9 of them had to pass. If you had 100 trucks, 90 of them had to pass. In this particular case, the delivery fleet should be recertified annually, not to exceed 14 months. So every year you had to come back and recertify the trucks. You had to recertify the trucks. Okay, so here was one of the things that had to be done. You actually had to climb up onto every truck and inspect the interior condition. What did the fins look like inside of the drum? Now, did I ever have to actually climb in the drum? No, I didn't climb in the drum. I had someone else do it for me. No, I'm kidding. You climbed up the top of the truck, you looked in the hopper, and you assessed with a flashlight the quality of the fins, because you knew what a bad fin looked like versus a good fin. I had to look at the hoppers and chutes. Somebody asked yesterday or 2 days ago about how do you know how many drum revolutions the truck has done. We actually have revolution counters on the trucks. You had to verify that they were working. So I had to have a truck spin, zero it out. 1, 2, 3, 4. Check this. I went to about 10. That was it. I didn't go to 300. I also had to check the water measurement on the truck. So somebody says they want to add water to the drum. Now, I realize that that's an issue here, but we still have carried water on the truck for a variety of reasons, whether to add it in there or to discharge it or something like that. So when we pulled the lever and water went somewhere, we have a meter, and it told me how many gallons, liters, were being discharged. We had to verify that, so you have to come up with a bucket, and you had to discharge into that. You had to know what the volume was, measure and evaluate that versus what the meter said. So we had to check that. Now that was important for us because when someone said they added 5 gallons to the truck, we wanted to make sure that it was 5 gallons. Now, all of that is for the plant certification. In the next 6 minutes or here or so, what I'll do is I'll just go to 10:15, and wherever I stop, and then I'll pick back up again at 10:30. So we also have a NRMCA quality certification program. This is a little bit different than the presentation. Now, if anybody would like to follow up on this, there's a couple of things. You can actually go to the NRMCA website. You can follow an online presentation. This is available free to the public. You don't have to be a member at all. Now, I've heard about the ISO 14000 and 14000, I believe it's 14001 concepts. Those are more on the sustainability side. I'm going to talk about that here towards the end. Right now I'm dealing with the ISO 9000, quality management system kind of aspect in the way the NRMCA approaches that. It's also tied, several people have asked me and talked to me, several of you might be familiar with something called the P2P initiative, prescription to performance initiative, moving us from that order, option B and C over to option A that I talked about in C94, moving us to a performance-based concrete versus this prescriptive approach. And so that's part of it as well. This is one of the things that helps with the development of a quality plan, a quality management system within a ready-mix company. This is kind of that stepped process that if you're going to produce a quality concrete, this is the roadmap on how to get there. So, the first part, big list of all the things that are part of this. This is a quality management system that you might be familiar with. This is what the NRMCA focuses on. Some of you might be familiar with this, but this is really gets to the heart of it. Now, there's a couple of parts there, a couple of parts that are key to, more key from my perspective than anything else. And I'll talk about those as I go through them. The first is having this quality plan, but you also have these other aspects here about personnel qualifications and testing capabilities. I thought in the last presentation there was an excellent slide that contrasted two photos about a quality lab of what one used to be or somebody used to think one was versus what now people were thinking about that. I also thought there was an interesting comment in there about there were some people that didn't know what a quality lab should be. Same kind of thing here about certification of personnel, making sure you have a quality level there. ACI, standard or certified testing technicians, how important that is in being able to evaluate. Now, the other part about that was when you're talking about the quality level of concrete and having a quality management system, there was the aspect of, I want an ACI certified technician, or we'll just call it a certified technician who's going to be evaluating the concrete. Was that for a testing lab? We had them internally, our technicians, our drivers had those certifications, because how do you know that a test is being performed incorrectly? You have to know the test, what the correct test method is. The only way to verify that was to have your own certifications in place. So our drivers had the option. What we did is we always told the drivers about every 6 months, hey, another ACI certification is coming up. Would you like to go get certified? There was not a requirement to do that. It didn't affect their pay scale. What it did was give them an opportunity to educate themselves and possibly advance their own careers. And the company paid for it. So now I'm much happier if I have certified driver, not only a certified driver, but a certified technician who is a driver. So that goes back here to the personnel aspect of this thing. So on this particular thing, quality manual, this is the general operating document for that company. You've got it in writing and it exists. This one here, this entire group block, this typically is somebody who you are working for or supplying concrete to that wants to know these kind of things. Now, the company quality manual, you can look up a variety of these, but these are some of the key things that are being looked for in the quality management system. If you have a company quality manual, you should have something that addresses these points. You should have something that talks about these points in your quality manual. Kind of, these would be your headings. Now, personnel qualification. Now, this was a challenge. And this is a challenge for people trying to achieve this certification, because look at what some of the requirements are here. So, quality manager. Do you actually have a quality manager? Now, I've heard some people say, well, everybody's a quality manager because quality matters to everyone. Do you have someone that has both the authority and the responsibility to make decisions about the quality of the material? So that's difficult for some companies because they have not thought here, and we'll resume. I'll start speaking again at 10:30, and then we'll take our break.
حطه هنا.
Yeah, I'll tell you what, let me back up and I'll bring you up here.
Okay.
Which one are you? I'll pull up the full site for you. Is that you right there?
Yeah, this
Which one?
This
Controlling?
one. Yes, this is the.
This one?
Yeah. But this will be after.
Yeah.
After.
Yeah, I'll switch it for you.
Okay, very good. And you have the your control.
It's right here.
Excellent.
Okay, he wanted.
So it's ready now. Huh?
Yeah, you're all set.
Hello, Doctor. Please, can you help me? I need to do.
Oh, you're going to make a presentation?
Okay. Huh?
Okay. Oh, this one. When do you, after lunch?
Okay, no problem.
I think you go after lunch, don't you? Yeah. Let's do it then. Yeah.
To the program.
Yeah.
Okay, exactly. Thanks. Thank you very much.
Okay, you bet.
هو الاي تي تابع لكم ولا شركه ولا كيف؟
بس مشكلة مشغولة.
لا هو انا اعتقد انه هذا هو اللي مشغلها هنا. هو حاطين طبعا الفلاش هو اللي فيه كل شو اسمه المعلومه، بس هو النقل من one فلاش تو انذر.
بس ما اقدر اسحب الفلاش.
لا لو سحبت الفلاش كل البرنامج اللي هو ما نزله. هذا الظاهر انه ما في هارد ديسك هو بيشتغل بالطريقه هذه. توصله بجهاز ثاني او بفلاش ميموري او كذا، فهي الفلاش هي اللي عليها كل المحاضرات which is good. اذا كانت بالطريقه هذه ممكن الواحد ياخذ بس منها كوبي. ايش الملفات اذا كانت مجموعه ملفات لما كل محاضر لا هذه مثلا شايف ال HTM سعودي كذا سيرتيفيكيشن، هذه السيرتيفيكيشن فقط يعني محاضرات في ملف واحد ولكن ليست كل المحاضرات.
هذا نعم ها حلو راحت بس انه ما قفلتها بس
لا هو ممكن هنا في رجوع لها شايف، بس قد تكون هي يعني عارف على المحاضرات، بس هنا المفروض انك
انت شو ممكن
لا احنا ما نبغى ننهي له كل الشغله لانه هو يرجع له اكيد. خلينا نشوف البريفيوس.
احسن خليها انا حياك الله ونحاول بس
دكتور عبد الرحمن
نحاول نحط على الموقع. بس المشكلة ما يعني في حاط فلاش ما اقدر اخذ شيء الان مشغولة كلها ما توصيات مشغولة. لا خلص of the pictures. Yes, good. This picture. Good picture.
The NRMCA is actually, I think they have one scheduled next month maybe in Maryland. But if you go to the NRMCA website, you can look up their concrete technician.
They can send invitation, you can attend this one time.
Yeah, you can go to the website and find out when they're offering it right now. I just don't know. I don't know the dates.
But annually they are making.
Oh yes, 3 times a year, I think, 2 times a year.
It's take maybe 1 month, 2 months, 3 months.
No, it takes. No, the course takes 1 week. Very intense. Yeah, 8 a.m. to 4 p.m. 4 days.
It's another work, very intensive.
Oh yes, and you get a certification afterwards. You have to take an exam at the end of the week.
But we are thinking about to go in detail, practically and.
Oh yes, I would highly recommend it. I've taught in it several times, and it's a very intense program.
So we can send to them.
Yes. Yeah. The. you very much. Yes. All right, I'm going to go ahead and get started here. We'll let people kind of come in as they come in. I'm going to finish right a little bit before 11:30, probably try to finish up at about 25. Allow for a couple of questions because I'm going to get our next speaker started at 11:30 before lunch. Okay, so let me kind of summarize where we finished up here about the quality management system and the certifications. So there was two that we talked about here. One was the quality management system. I don't think I need to repeat the importance of that, the impact that that can have on your concrete, your company, and more importantly, and I think this is the biggest point, is my experience has been once the purchasing community begins to understand which companies have the higher quality of concrete, which companies can show that they have the higher quality and with a certification can prove it, that someone else says the exact same thing, I had always found that that gave a competitive edge in the marketplace to the producers. And then if I was a user of it, particularly if I was a government entity that had a concern about that, or I was building a government road, transportation system, structure, having the ability to prove that, I would think would give me confidence as the ultimate owner of that project as well. The other thing here, the quality certification, this is the interesting part here, is this statement. Sets a minimum standard. Sets a minimum standard. But the difference is, and the important part about that is, it doesn't set the minimum standard to the lowest common denominator. And that's the key part of this. It sets a minimum standard that does not go to the lowest common denominator. It raises the bar up. It raises the level of quality up. And if you want to continue to move that up, you work within the system. All right. I'm going to start talking about the environmental plant certifications and the sustainability aspect of it here in the last little bit of time I have, because this is a natural progression. This is a natural outgrowth of plant certification, but it's also from a community standpoint, from a construction standpoint, and from a global emphasis on green building, sustainable design, sustainable construction, green construction. Now do they not just want to know how the building is being built, but where the material is being sourced from. Are the people sourcing the material sustainable? Are they having a minimum impact on their communities? This is the process by which we're evaluating that. So, the Green Star program is the name of the program. But what this really does is it recognizes ready-mix plants that use the system. It's another way of recognizing the plants that are achieving those goals. So, benefits of Green Star. Look at the second point there. Major specifiers and DOTs, that's Department of Transportation's, are asking suppliers to participate in this. Remember what I said earlier about the inability to respond quickly with this? Oh, well, we can just go hire somebody. You can't just go hire a Green Star certification. You have to have that already done. And if you attempt to do it now, today, you're talking about months. You have to find the person, you've got to get the system in place, you have to get the documents in place. It doesn't happen overnight. You can't buy this. So to be able to comply with these requirements, you actually have to have it. So, two things, benefits here. One, I've seen these on the increased revenue side as a ready-mix producer. My ability, two things. I had less competitors, and if someone wanted a specialty product, if someone wanted me to have a specialty certification, what was I able to do in the marketplace? I could charge more for that, which we did. The other thing was the improved efficiency here. I actually saw an efficiency go up in the plants. So, as in the last couple of days, I had heard this phrase used several times about wanting to speed up a process, wanting to move batching faster, deliver faster. You were talking about improving efficiency. Many of these certification programs actually improve efficiency without decreasing quality. They improve the quality and improve efficiency at the same time. That's a hard thing to sell someone on because they may see it only as more paperwork and more rigorous testing and more rigorous controls. The benefit of it on the backside was, I can tell you, we got more efficient. Not only did we get better quality, but we got more efficient. We were just talking about this during the break, about community goodwill, about public relations with a plant. Where you live, in your homes, if I told you I was going to put a concrete plant next to you today, would you be happy about that or sad about that? Why? Are they noisy? Are they dusty? Are they loud? Those kind of things. Community members know that, and we know about those plants. There is a certain amount of participation within the community that the plants have to do. When I build a plant, I don't like to pick it up and move it. In fact, I never pick up a plant and move it. When we build it in a spot, it stays in a spot, which means as the community grows around us, we have to integrate ourselves into the community. We have a certain amount of community goodwill that we need to exercise, and certain things do that. Reduction in liability risk. I don't know how much of an issue this is for you here. We have, I'm sure that you're aware of, we have a lot of lawyers in the United States. And so we are always conscious of that when it comes to certain liability issues. There's certain components here, environmental policy. Notice here, strong management commitment. This is always one of those aspects of, oh, you hand it to somebody who's going to put it in place and they'll fill out the paperwork. Remember when we went back and I showed you the first certification, who it was signed by? It was signed by a president of the company. Having the management commitment that says this is what we're going to do in the community, this is the reason we're doing this, is a very important aspect of it. The Green Star program is a self-evaluation program. It means you perform the audit yourself. The other part about this is making sure that you get the training for there. There are certain places you could go. SASO would be an excellent organization if you had a national ready-mix organization here in the kingdom. Another great place to get some kind of training on that. Here's the other thing is, remember I asked you the question, would you like a ready-mix plant next to you? We actually, as part of this, invite community members into the plants. Now, this is a great picture of a truck driver with a truck and a bunch of kids here and those things. You know who the most important people are to invite into your plant? It's not the families and the kids. It's the local civic authorities. It's the local civic or municipal authorities to come in and say, this is what our plant does. This is what it looks like. See, it's not scary. It's not dirty. It's not dusty. And when you do have a complaint about it being noisy or loud, this is why. And because this is what we do here. So many people misunderstand what happens. That's why we invite them in. Okay. Here's all the issues, the Green Star components: water quality, air quality, hazardous materials, community, and sustainability. This is part of the program. The average time to do this, about 8 months. This is not a short period to do this. I can do a plant certification in 2 days, but this takes much longer because of the environmental issues. All right, I wanted to move through that quickly because I really wanted to get to this part here on the NRMCA Sustainable Plant Certification. This is the big one. This is the issue about sustainability and showing the sustainable impact, the environmental impact that your plant has on the community. Now, this afternoon, I'm going to talk about, I've thrown this term around, I've used this term 3 times, sustainable. If I asked everybody in the room to write down a definition of what sustainable was, we have 50 people in the room, I'd get 52 definitions. I'm going to define it for you my way this afternoon. But in this particular case, when you say green, when you say sustainable, there's always a metric there, a measurement. In this particular case, this is what defines and constitutes a sustainable plant. So, there's actually a guideline here. If you'll notice, this is March 2011. The other plant certification was 1966. 1995 was another one. This is 2011. This is only 3 years old. That's how recent this is. That's how current these kind of issues are. So, let's look at the guideline itself. This is not a quality issue. The other thing was the quality of the concrete as you batched it. This is the impact. Look at the different parts. Material acquisition, how it's produced, construction, product use, and recycling. They're organized around those 5 things. Notice in there, it's not even connected to the other certification, which was testing, batching accuracy, measurement, managers. That's not part of this. This is completely different. Now, could I have both certifications? Yes. Could I have one and not the other? Could I get the plant certification and not the sustainable one? Yes. Could I get the sustainable one and not the plant certification? Yes. You can. We'll go through that. All right. Here's the categories: energy, carbon footprint, water, waste, recycled, social concerns, and human health. This is why the 2 things are completely separate. Look at those categories and think about the context of my earlier presentation and the presentation before me that talked about quality management. Completely different. So, we also had to come up with the metrics. Where did those come from? This is the other part. You had to collect some data. So we had to go out to the industry in 2009, collect information from the industry, and then we had to establish a baseline for which we could begin to measure from. Now, here's how the points are divided up. We use a point scheme, and that's how you establish, just like the earlier presentations have shown. Look at how they're set up here. 52 points. Half the points are on how you produce it. The other biggest category is on material acquisition, where the material comes from. We'll talk about that as well. And then there's a couple of things down here. So we actually give a rating system. Now, platinum, gold, silver, and bronze based on your point system, just like the A, B, C category. Anybody else know what this scheme looks like here? Just like LEED. Everybody, U.S. Green Building Council, LEED. Leadership in Environmental Energy and Design program. Right now, of the programs I'm aware of, it's about 80% of the metric systems are measured against LEED. Matches right up there kind of from a standpoint. All right, prerequisites, compliance with environmental management system. Did you notice that was the presentation right before this, the slides? So you had to kind of have that there. All right, material acquisition. Look at the points and how they're spread out. Not the value over here. Recycled aggregate. Optimized Portland cement use. Optimized Portland cement use. How do you show that? How do you show optimized Portland cement use in your mix designs? Well, now all of a sudden in your mix designs, we're going to start looking at, are you using the lowest possible cement to achieve the strengths? Are you using pozzolanic replacements? Materials transportation analysis. How's the material being transported and from how far? How many miles are those materials coming from? Now, why is that important? Because every mile that an aggregate or cement has to be transmitted or transported has emissions. The shorter the distance of transport, the lower the emissions. Now, from a production standpoint, look at the categories here. Dust emissions, reduction of fresh water. Go back to the ASTM C94 allowances, or multiple water sources. This is reduction of fresh water. Fresh water here means municipal drinking water. Reduction of fresh water use in batching. Process water collection and treatment. I used a comment earlier about how we shape some of our plants like funnels. I don't think you have as much of an issue here with rainfall that we do, but when it rains, we don't like a single drop of water to leave the facility. Every drop of water that falls onto the plant, we want to keep. We want to keep it for 3 reasons. 1, environmentally, it's very difficult to manage the solids and the pH of runoff, so we don't want to have to deal with either one of those. And the third thing is, every gallon of water that I capture is a gallon of water I don't have to buy. There's a cost there. The fourth benefit is I get to recycle and say I'm recycling. Stormwater management, proper storage of chemicals. Oh, the list keeps going. Carbon footprint. How do I reduce the carbon footprint at a plant? How do I reduce the carbon footprint at a concrete plant? Particular case. Excess concrete reduction, diversion of return concrete from disposal. Now, yesterday I asked this question, or maybe 2 days ago, I asked this question. What do you do with the concrete that's left back in your truck? Now, I told you at ASTM, we've been working on how to deal with that, what's called top loading. We put concrete on top of it and send it back out the gate. That counts. But what if I can't do that? What do I do with the concrete that comes back? What do I do with the material in the drum even if there's no concrete that comes back and I'm just washing off the truck. I'm washing out the drum and rinsing it out. What do I do with that material? Where does that go? Does it go into a settling pond and I reclaim the water that comes off of it? Does it go into a concrete recycler? Anybody in here familiar with a concrete reclaimer or concrete recycler? Anybody ever seen one of those? Best way I can describe it is a giant washing machine. You wash the concrete into it with some water. It spins it around. The aggregates, the slurry drops out of it. The aggregates come out of it. They go back into the stockpile, and then the slurry goes into a pit. It settles, and we pull the water off the top. There's 2 in Jeddah. Almost every plant that I know in a big metro area has one. One, because every pound of aggregate that I can pull out of there is a pound of aggregate I don't have to buy, and it's a pound of aggregate I don't have to dispose of. So all of a sudden, how you set up a plant becomes important now. So if I was going to build a new plant today here in Riyadh, I would have to kind of think about some of these if I was going to go that direction. And right now, it's not just because I want this certification. That's how we build plants now. That's how we do things now. This is now part of how we supply concrete. Additional sustainable practices, what does that mean? Do you have a trash bin in your office that has paper products and recyclable products? Do you use fluorescent light bulbs or incandescent light bulbs? Do you have a recycling system with your plumbing? Those are additional practices that you can do at your plant, at your facility, that you can actually get credit for. Oh, notice here, this certification is only valid for 2 years. Only 2 years. You have to come back and recertify after that. Now, if I'm thinking about doing this, where would I find out more information about this? So, Sustainable Concrete Plant Guidelines. Now, again, notice March 2011. Here's environmental management in the ready-mix concrete industry. Again, these are documents that you can download right now today from the NRMCA, publicly available. This is the other thing, is that whether this is the NRMCA, whether this is the National Ready Mix Association here, whether this is SASO or any of the other groups, one of the key aspects to getting acceptance of any of these programs is transparency and availability. Anybody can ask a question, anybody can see what the requirements are, and anybody can have access to it. You don't have to purchase it. You can download it and it's available. The other thing I like about that is I can hand this to somebody who doesn't know. Not somebody in our industry. Remember how I was talking about how important the aspect of the community is? Those civic leaders in a community that don't know about our industry. They're not engineers, they're not scientists, they're not producers or consultants. But we can say, this is how we do things. That's very, very powerful and very important, is the ability to be able to show somebody, yes, this is what we're trying to do. Okay. Data collected 12-month period. This is the other part of why the 2 years are important. This is one of those things where we want the information being applied to be the most current available. So this is, again, one of those things where somebody says, oh, can I get your certification? Sure, we could just go buy it. You can't. Now, I was fortunate one time that we were expanding our company, and I was actually able to buy another company that had one of these there. That's how we've gained it very quickly. We bought the company that had a certification. Now, we didn't intend to. They were just part of our growth plan. But that's how we gained it first, once we had it, we realized the benefits of it, and then we expanded it to other plants. Now, dust emissions, this is, we're going to go into a little bit of detail here. They start calculating your emissions. So now we're going to look at your emissions. I had talked to you about how important those were. Look at the spreadsheet here, and it talks about cement delivery, pozzolanic delivery, cement pozzolanic weighbatchers, coarse and fine aggregate transfer, truck loading. These are all point sources of emissions. Every one of them is evaluated in a checklist. It's exhaustive. It's very, very intense. Reduction of fresh water. I may have lied a little bit when I told you about the most technical slide a couple of days ago. This one actually has a math equation in it, so I'm going to say that this is a technical slide too. In this particular case, non-batching freshwater use percent below baseline, and this is that baseline. Remember how I told you we collected the data in 2009? That was to establish the baseline, and that's what this number here is here. The problem is, as the plants get more and more developed, more and more green, the baseline keeps moving up. That was the other reason why every 2 years they wanted this recertified. Okay. Here's the other one, reduced carbon footprint. Reduced carbon footprint. So, in this particular case, notice here at the bottom, submit a copy of the CO2 calculator's output page. There's a calculator that tells you where to put your input in. It will calculate your CO2 tonnage or pounds for you, kilograms for you. And then here, this is the equation used to evaluate it relative to the baseline. This is one of the more difficult concepts to grasp about some of the ready-mix plants, is this aspect of carbon footprint. How to calculate the carbon footprint at your plant. And this for here, it takes into a result all of these things, energy, transportation, and then it gives you your average annual carbon footprint and your average annual energy use. Now, why is that so important? Because the next time that somebody comes to that plant from the community and says, we have an issue, you're loud, you're noisy, you consume too much energy, you can say, here's how much energy I actually consume. Here's my carbon footprint. Do you have that for somebody else you're concerned about? It's a nice tool to challenge or combat the concerns people have about our plants and industry. Now, exhaustive spreadsheet. Don't even bother trying to look at it or read it. What I'm saying is that this is how detailed it gets when it starts asking questions about energy here. This is the carbon footprint calculator. It's huge. But that's the amount of detail that's needed to calculate. Now, if you look at the carbon footprint, this is a pie chart that takes a look at the life cycle here. Now, look at the percentages. Nope, those didn't translate well. Material and manufacturing, ready-mix plant operations, and transportation to the site. That's transportation to the site. That's the ready-mix plant operations. This is all material manufacturing and transportation. Remember what I said earlier about the emissions. The biggest part of your emissions is in your transportation fleet. This result proves that and shows that. This is the numbers here from the previous slide. Ready-mix plant operations, transportation to the site, materials manufacturing and transportation. Short tons, 81,000, 2,000, 3,000. Big difference, and that's what the sheet calculated. Those are the real numbers. All right. Biodiversity, we talked about this one. Create a habitat, visual berms. Now, this is my favorite. These are the two ones I focus on more than anything else at the plants that I work with. These number 4 and number 5. Visual berms, enhancing the visual berms. What that really means is, can I limit somebody's sight onto my plant? We would put up berms and then plant trees in them. We'd plant bushes on them. So when somebody looks, they don't look at metal and they don't look at trucks and those kind of things. They actually saw something that was visually appealing to them. Even when we put up concrete walls, we tried to do something with the concrete walls and give them color, give them a texture, and then put bushes or plants in front of that. The other thing is with our settling ponds. We didn't just make one settling pond for water, we made 2. So we had to clear water. Now the problem we ran into was we made the ponds too big and we actually got birds that started migrating and forming a habitat on those ponds. Then we had another problem because now we had migratory birds. All right. In this particular one, here's a couple other examples that you can get here. All right. Excess concrete reduction here. Return concrete as a percent. Annual concrete returned versus annual concrete delivered. This is a calculation you could do right now at any one of your facilities, at any one of the plants that you work with. This is not a hard calculation to do. But I would challenge you, go ahead and do that calculation and really find out what's the annual percent. First time I saw this, I did the math at our plants, and it was amazing to me the difference from plant to plant to plant, because some plant managers were making local decisions that others weren't. And we found out that, wow, those two guys over there really were doing a good job of recycling and reclaiming the material. And these guys over here were just dumping it because it was easy. Diversion of concrete from disposal, again, another equation here. And here's how the points were. It was based on the percent and those results. I would dare say for you, we will establish a baseline on the numbers coming in and then challenge people to continue to move ahead of that. Other recycling initiatives, here's some examples. Provide appropriate facilities for on-site collection. I told you about garbage cans. Just simple things as garbage cans that separate waste versus recycled materials. That's a big benefit and a big help. Those of you that are used to taking in other products, things that are bagged, things that are on pallets, all of those kind of products can be recycled to a certain extent. And so that's all they look for. Do you have something like that? We even wound up putting recycling buckets in the office and got credit for that. Now, okay, I finished a little bit early. Is that so? I wanted to, because I wanted to leave time for some questions here, particularly about this aspect. And I'm going to really talk this afternoon about sustainability. Before I turn it over, does anybody have any questions on the plant certification, particularly the sustainability aspect or anything like that? Any questions for me there? Yes, sir.
I thought that this green environment is very important, very, very good part. What your introduction about us. But you know, newly there is another research. They are talking about the radiation of the components. And I don't know, is this related to environment or no? Because, you know, we studied before that some of the materials of the concrete, they have a little of radiation. And this is that anybody that can affect it in the closed area. So where is this in the green environment about this?
You're speaking about radon or radiation?
Yeah. I'm talking about
radon.
Yeah, the content, because there is a concrete and there is another material. I don't know in English what's translation. We named rukham, mujir, and like this and this is they are affecting on the guys. So where can we find this in the green environment?
Yeah, the only thing that we have been addressing from an environmental hazard standpoint is something called silicosis. exposure to silica, silica dust, those kind of things. And the only place that we've really run into that is either in a quality control laboratory or on somebody who's working in a quarry. Because the measurement of silicosis and the availability of things that cause silicosis at a ready-mix plant are pretty minimal unless you are standing in a stockpile of sand and throwing it on yourself.
But the design, full control. My question is, now we are talking about the design. There is a patching plant.
Yep.
They come, so they want the business. So they want, as you said, they want the efficiency without quality control. So we are talking about, sometimes they are making design that it's commercially success. But how we can know that this is environmentally success also in the design of the material use?
Yeah, let's talk about that during the break. How's that? I'm having a little bit of trouble understanding what you're asking, but let's talk about it during the break.
Okay, Dr. Richard.
Yes.
Okay, in the previous presentation, we know that the certified for concrete plants is optional. Okay, so what is the percentage of uncertified to certified in the States? Also, what is
from 2008 to now? I joined U.S. Green Building Council at 2008. In May 2008, I take the first course of Green Star. I was the only one from Arab and Muslim world. It was 3 only in USA have Green Star with Mr. Roland. And then I asked him to come to Saudi Arabia in November 2008 to Jeddah and Riyadh. 1,000, had attended this to lecture. At that time, there is one only in Saudi Arabia who get Green Star. Is the only one outside USA. Now we have 160 outside USA. Yeah. At that time, 3 in USA. Now more than 1,000. And there is now some book that join the effort between LEED, NRMCA, and Green Concrete. And so it's huge. It's save our natural resources, reduce the waste,
yes,
save money, and reduce the pollution. And very good progress. Thank you.
No,
I was planning yesterday to ask you a question about Green Star, but now you have 2 hours about it. Thank you. Thank you much.
It's good planning on Sasso's behalf. Yeah. Oh, sorry, yes.
I would appreciate if you can cover the control of quality at the construction site, the responsibility and, the system, because I think this is a major difference between the state and here. Here we have the small construction site, no control at all. Okay, as I know in the state, the picture probably is much different.
Yeah, it's a very interesting question. So I'll highlight for you an example of how it works in the States, because I don't know the concept here as well, but so what happens is I'm a ready-mix concrete producer. I have the truck, I have the specification, I produce the concrete, the plant is certified, the people are certified, but as soon as I get to what we call the curb line, as soon as I get to the curb line, it's still my concrete. As soon as I get past the curb line, it now becomes somebody else's because it's coming off the truck. So the quality of what happens afterwards in terms of construction, consolidation, what we call methods, materials and methods, I'm in charge of the materials side of it. The methods part of it, the installation, the consolidation, the finishing, the curing, all of that, I have nothing to do with at all. And that's not just me, that's the states. That's the way we look at it. Now, the problems come from the method side when all of a sudden somebody says, we have a problem. Well, then we say, is it materials or methods? Well, wait a second, I've got a qualified plant, I've got qualified people, I've got all of my mixed designs, I've got engineers, I've got everything. Well, could I have a materials problem? I might. I think I had said yesterday, when I have somebody tell me I have low brakes somewhere, my first concern is not that project. My concern is if I have low brakes somewhere, My first concern is if I have a materials problem, who else did I supply concrete to that day that I supplied concrete to that has a problem? But when I find out that the problem is isolated to that one particular project, now we start diving into it's a methods issue, it's a testing issue, or something like that. Because in most cases, the materials problem, unless it replicates itself in multiple places. So no, our responsibility for quality stops right here.
Richard.
Yeah, let me go here first.
The crushing plants, basically, they are one of the major source of pollution in the country, but because they are mostly far from the cities, somehow the universities and government bodies are not able to control them, I think.
Yeah, his question is about the quarries. And what do we do about quarries, crushing plants, those kind of things, sand plants, gravel plants? I'm going to talk about that this afternoon, and if I don't address it appropriately, ask your question again. But I'm going to talk about that this afternoon when I talk about sustainability, particularly with something called product category rules and environmental product declarations.
But my question, if some government authority is planning to do something about them or not, I mean, to the room, is my question, basically. The universities or...
Yeah,
no,
I'm probably not the right person to ask about that.
I mean, anybody can answer.
Yeah. I'll tell you what, I'm going to go ahead and pass my time up to our next speaker, and then of course, I'll be around during lunch, questions or those kind of things. So,
Richard, excuse me, last question, please. About you talk about the returned concrete.
yes.
Right? What about the rejected concrete in USA? How you are doing it?
Oh,
Rejected concrete.
yeah. So his question was the rejected concrete. What happens there? It goes out to a job and somebody rejects it for whatever reason. So first thing is, let's say it's legitimately rejected. There's a problem with the concrete, the truck comes off of the job, and now it's back to me. It's my concrete. Well, as you saw from some of the schemes, there's certain things I can do with it. First is, I would like to know why it's rejected. Can I put it somewhere else? If I can't put it anywhere else, then I bring it back to the plant and I'll recycle it. There's nothing wrong with that.
Can I use it in lower grade of concrete? For example,
could I use
instead of
it?
35 mega,
Yeah.
I can use it for blinding concrete.
Absolutely.
Is it,
But you have to have a quality manager capable of making that decision that knows all the information to make that, because that's a risk. And for the company, for my company, that's a big risk. So I have to have somebody I know that has the level of education and experience that they can make that decision. Otherwise, bring it back to the plant. And here's the other thing is, we don't run the risk. If we can do it, we do. But if we have a question, bring it back to the plant. I don't want that risk. I'll recycle it, I'll reclaim it.
Thank you, Dr. Richard. Our next speaker, Ridwan Hamid. He's a technical and R&D director at Saudi Ready Mix Concrete, fellow of Concrete Society UK, board member of ACI, Saudi Arabia chapter, member of ASTM, SCE, and speaker at many conferences. He has several publications in local and international periodicals. حيتحدث الأستاذ رضوان حميد عن التحكم في جودة الخرسانة الجاهزة من المصنع إلى الموقع. فليتفضل.
شكرا جزيلا. Assalamu alaikum and good morning. I will highlight in my presentation the main and key points that need to be considered in order to end up with quality concrete in the structure. It's not only the quality of the ready-mixed concrete that's produced that matters, but also, as Richard mentioned, that there are methods and other steps after reaching the site that are equally important in order to end up with a good quality and durable structure. Before I start, I'll just give you a brief introduction about our company, Saudi Ready Mix Concrete Company, which is the largest ready-mix concrete producer in the Middle East. It was founded in 1978 and merged with Inma Trading in 1998. Our vision is to be the most trusted provider of concrete solutions, not only concrete solutions in the Middle East. We are spread in the eastern region, central region, and the western region. We have about 20 commercial plants and more than 15 on-site plants, and the number is increasing. We have 2 quarries, 3 block plants. We are members in many international organizations like ACI, ASTM, NRMCA, and the British Standard. And we train and qualify and certify our staff in many also with many programs like City and Guilds, ACI certification, NRMCA, concrete technologist, and in the Middle East. We are ISO 9000 certified, we are ISO 14000 certified, and we are ISO 18000 certified, and we have other certifications as well. To go into the subject, as you know, concrete is the most widely used construction material in the world. As a matter of fact, it's also the second material consumed in the world after water. In Saudi Arabia, every year, about 70 million cubic meters of concrete is produced. Saudi Ready Mix Concrete Company, as an example, our company, produces about 6 million cubic meters of concrete every year. Just to imagine what does 6 million cubic meters of concrete means. If we have a beam of 1 meter by 1 meter and 6,000 kilometers long, this is the distance from Riyadh to London in UK. This is what 6 million cubic meters of concrete means. In the last 14, 15 years, the concrete industry has changed. I remember like before 10, 15 years, we were only asked to supply concrete of maximum 5,000 PSI. And all the concrete is normal concrete. But now with the change in the requirement, we have high-rise buildings, requirements for green concrete. Some projects are seeking the LEED approval and certification, requirements for the sustainability. Now the introduction of durability requirements in the projects, change in the raw materials. Before several years, nobody was using GGBFS or slag cement in the market. I remember like 4 years ago, it was the first time that we used GGBFS in the CMA Tower, where we poured about 12,000 cubic meters of concrete in one shot for the foundation of the CMA Tower, and we used GGBFS at that time where we brought the GGBFS from Qatar. But nowadays, the demand for GGBFS is increasing. Even we have now a grinder for GGBFS in the Eastern Province, we cannot meet the demand. The demand is increasing more and more. We find it in the project in the West, East, and even in the Central region. The equipment has changed, the pumping equipment, the delivery equipment, so many things changed. This led to the generation of new types of concrete, like high-performance concrete, high-strength concrete, high-durability concrete, self-compacting concrete, pervious concrete, concrete with low heat of hydration for mass structures. For such types of concrete, we need stricter quality control, and we need more effort in order to control the quality of the concrete. And this control starts, as mentioned yesterday in one of the topics, starts by the specification. So the proper international or local specification and standards need to be used and adopted. And one of the examples is the ASTM C94, the specification for ready-mix concrete This is one of the best specifications that can be used for any project, and then you can customize it locally for any environment. And if we go to the project-wise, project specifications need to be written and reviewed by professional concrete technologists or concrete engineers. I know you can find in the market very excellent structural engineers, but some of them, they don't have the concrete technology knowledge. So this needs to be reviewed by people who have knowledge and experience about the concrete technology. So if we are specifying or designing a project in Riyadh, the specification shouldn't be the same as if we are specifying or designing for a project in the eastern region where the weather is humid and where the concrete will be very close to the sea. So each project, depending on the nature of the project, the exposure condition, the durability requirement, the sustainability requirement, the service life expected for the project, each project should have its own specification of the concrete. We have seen that one of the projects in the Eastern Province, the specification we're asking only for normal concrete. It's just like a villa market concrete, but it was a requirement also in the project specification that they want service life for 100 years. So we said this is not possible, that to have this concrete without any material, just normal concrete, 4,000 PSI concrete on the sea, and you want 100-year service life. So all the specification has been changed now for that mega project. Also now there is a trend to change from prescriptive to performance, and we believe that moving to performance specification will benefit all parties involved in the project. Concrete supplier needs also and shall have a clear and approved implemented quality management system. One of the quality management systems that I think everybody is now having in Saudi Arabia is the ISO 9000. But also you can go for the quality scheme for ready-mix from the UK. This is a very excellent program because it's like the ISO 9000, but it's specialized for the ready-mix concrete industry. And also you can find the quality management system prepared by the National Ready-Mix Concrete Association. This is a very good guy, and you can use it and you can build on it. The quality supplier, the concrete supplier also should have a quality control program for all the materials testing, for the production, for the equipment, and to control the quality of concrete he's producing. This is an example of our inspection and testing plan, where you can have what test you need to perform on all the materials, and the frequency of testing, and what standard of testing you need to do. So this has to be implemented. So every material entering the plant need to be tested and checked. So if we start with raw materials, the quality of the raw material starts by qualifying the source of the raw material. If you have a good input, then you are going to have good output. You cannot get bad input and then end up with a good input. So the sources and suppliers of raw materials need to be qualified and assessed, and then all the materials coming to the plant or going to be used in the production of concrete need to be also tested by certified technicians in order to make sure that all the materials, whether cement, aggregate, admixtures, are complying to the required specifications. Material management is also very important, and it was discussed in previous lectures that you need to know how you are handling and managing the material in your plant. Are your aggregate in stock base, shaded? Are they isolated with barriers and walls in order to prevent the contamination and mixing of different sizes of aggregates? Are your silos watertight, especially in the humid areas? Are your admixture tanks covered also, and they are under shade and they are really tight, and you have agitators that mix the admixtures inside the water admixture in order to not for the settlement of the admixtures. So all these and others are very important in order to assure that you are having a quality concrete. The concrete supplier should do the normal quality control test for the raw materials required for the fresh concrete, hardened concrete, and for the all raw materials. But in our company also went further step. As Dr. Richard said yesterday, when he compared the two slumps, you have seen two slumps with different viscosity. So we cannot depend mainly on the slump test. So we got a rheometer, and we are now using the rheology of concrete in order to do our mix designs, to control the mixes, and also we are using our rheometer with the research with the universities in the eastern region. We have joint researches there. Here, Dr. Olafur Walavik is giving a training about the rheology and about the rheometer, where you can see also in the chart where you get the plastic viscosity with the yield stress, so you know exactly where is your mix is, and then you can adjust it accordingly as per the requirement. Also, we use for the heat of hydration, we use calorimeter, like the IQ drum, you can see it here. This is very beneficial, where we test the heat of hydration of the concrete in the lab. Instead of doing a mock-up on the site and wasting time on concrete, we can run the test on the lab, and then we can get the maximum temperature expected and the minimum temperature and the differential between the high and the low temperature. Also, we can feed for the project what's the size of the structure, dimensions of the structure, what's the expected ambient temperature, the wind speed, and then automatically it will simulate and it will tell you whether you are going to have thermal cracks in your structure or no. Then according to that, we adjust our mix by either adding GGBFS or fly ash in order to reduce the heat of hydration. So for the mix design, the objective is to have acceptable properties in the plastic stage for the concrete, so the contractor can place, finish, compact, and the concrete easily, and also acceptable properties for the concrete in hardened state, so the owner will get concrete with the required strength and durability. But of course, this should be economical. Everybody can design any mix which will be safe, but it should be also at the same time economical. And this is why we need to do optimization in order to make economical mixes, and at the same time, as mentioned, we have to reach to some sustainable mix designs. And please remember this rule for the concrete. To be, whenever you want to do a mix design, to be durable, concrete must be impermeable. So if you want to increase the durability of your concrete, reduce the permeability of the concrete. And you can reduce it during the mix design by using supplementary cementitious material like microsilica, fly ash, or GGBFS, or you can use some other materials, chemical admixtures that can reduce also the permeability of the concrete. After doing the mix design and you want to start the production, then the first step is to go for batching. And by batching, we mean measuring the raw materials and then introducing the raw material into the mixer. This is called batching. And the sequence of batching, which material to come first into the mixer is very important. Whether to start with water, aggregate first, or cement first, when to start, what's the difference between the cement and aggregate, what's the time? Will I start the water from the beginning till the end, or I start at the beginning and then at the end I put more water? This is very important. And the batching sequence need to be done and some exercises by the producer in order to reach to the optimum or the best scenario of sequence of batching that will give him the uniform and homogeneous after the mix after that. Calibration of the scales is very important in order to make sure that the quantities that you are introducing are within the acceptable tolerance of ASTM C94. So now all the materials are in the mixer, whether we are talking about drum mixer, band mixer, or twin shaft mixers, doesn't matter. So we need the optimum time for mixing. Mixing is very, very important. And you need to run also exercise in your plant to reach to the optimum mixing time. Over mixing or under mixing will affect adversely the properties of the concrete. So if you are using a drum, different than a pan mixer, different than a twin shaft. So you need to find out what's my optimum time of mixing. And also what's the condition even of the mixer. Is it an old mixer? It's a new mixer? The blades of the mixer, are they in good condition or not in good condition? So all this will affect the mixing and the mixing time. After mixing the concrete, we need to transport it to site. So it's very important now to decide what's the distance between the plant and the site. We have to know that. Also, we have to consider what's the traffic condition. Are there any obstacles? Will be any delay during the transportation? These need to be taken into consideration, as well as what's the ambient temperature? Am I transporting the concrete during noon, or it is afternoon, or it's in winter or in summer? The requirements here, of course, and in the standard is to deliver the concrete within 1.5 hours from after batching and mixing, or the required revolutions. So in order to achieve this, and in order to make sure that you will meet this and you will deliver your concrete to site with the right quality, then you may need to use the admixtures. And you need to know what dosage of admixture I need to put, how many liters of admixtures, of retarders, or of superplasticizers that I need to put in the plant in order to make sure that when I reach to the site, then the concrete will be in the required properties. And the proper interval between the trucks leaving the site, this is very important. We don't want all the trucks to reach to the site and then queue in line and wait for a very long time, because trucks are waiting for a long time. The slump will drop, and maybe we'll reach to the initial sitting time, and the temperature within the trucks will also, that of the concrete will increase. But also if we delay big time between one truck and another truck, then maybe the concrete on site will sit, and then we will have cold joint. So it is very important to have good coordination between the plant and site, and taking into consideration the traffic and the distance, and to decide what interval I need to dispatch my trucks so they will reach on time there without any delay on site. As Richard said, the responsibility of the concrete supplier will end after the concrete reaches to the site and the blasting starts. So from that point on, everybody, I think, it's the responsibility of everybody, the concrete supplier, the contractor, the engineer, on site, to make sure that no water addition on site to the concrete, extra water addition is allowed. And this is, in Saudi Arabia, it's not allowed at all to retimber concrete with water. Even in some companies, they do not allow to retimber the concrete with chemical admixtures to adjust the slump. And it's very important for the concrete to be placed as close as possible to its final location. In some instances, you can see in some sites that concrete is piled in a heap, and then they start moving the concrete horizontally. This will cause segregation for the concrete, and it will cause problems. And maybe after that, the concrete supplier will be claimed for the quality of the concrete because of segregation and other problems. And concrete should not be dropped freely for more than 1 meter in order to avoid segregation and other problems. This limit can be increased if you are having self-compacting concrete, well-designed self-compacting concrete where the stability is more, so you can drop the concrete even for 5 meters freely without any problem. Hot weather concreting should be observed and practiced in order to avoid plastic shrinkage cracks and other problems. This should be between the contractor should be prepared for that, and the concrete supplier also should do his task in that aspect. After placing the concrete, then come for the compaction and consolidation. And the objective of the compaction is to get rid of as much air as you can from the concrete. Because if you have entrapped air, then for each 1% of air, additional air in the concrete, there will be a reduction of 5% of the strength. So if you have like 3% of air entrapped in the concrete, then your strength will drop with 15%. And if you have more air in your concrete, then the permeability will increase, and then the durability of your concrete will decrease, and also the bond strength between the steel and concrete will be less, and there will be also some other visual blemishes like blowholes and honeycombing. So in order to make sure that you are compacting the concrete very well, you need to have the proper sizes of the vibrator, Booker vibrator. You cannot use small vibrators in very big sites. And you need to have also enough vibrators. You cannot use only 1 or 2 vibrators in a very big site. We can see it on the sides that some people, they will just vibrate on this location and move for another location and continue the vibration, but all the area in between, no compaction at all. So the duration also of the vibration is very important. You need the people who are working and doing the vibrator, the laborers, should be experienced to know for how many seconds they are inserting the vibrator and then removing it. Because again, over vibration will cause problems and under vibration will cause problems. And how to use the vibrator itself, not pulling it horizontally on site, and how to dip it, when to remove it. This is also very important in order to make sure that the concrete is compacted and consolidated very well. In some cases, you cannot compact the concrete. If you have very congested steel, if you have very deep and narrow structures, or if it is underwater, or like piles, you cannot vibrate the concrete in pile, then it is recommended to go for self-compacting concrete. And we have poured self-compacting concrete successfully in many projects in the kingdom. And one of the projects which we are proud of is the head office of our company, which is a 16-floor building. We poured it completely with self-compacting concrete from the foundation to the floor number 16 without using 1 single cubic meter of conventional concrete. We used 20,000 cubic meter of self-compacting concrete. Finishing also is very important. And the 2 laws of finishing which need to be remembered, that no finishing work shall be done while there is bleeding water on the surface. So like screeding and ball floating should start before bleeding. And once there is bleeding water on the surface, then all the finishing work should stop. When there is no bleed water on the surface, then the finishing will continue by the floating and troweling. Otherwise, you will end up with a very weak surface layer on the surface, and you will end up with dusting, crazing, scaling on the surface. So this is the first law. The second law, while doing finishing, it's not allowed at all to add extra water or extra dry cement in order to do the finishing. This will cause also dusting, will cause grazing, will cause cracking, very weak surface layer, cannot resist any abrasion. So these two laws for the finishing should be remembered by the contractor while finishing the concrete. The final stage is the curing. And curing is very, very important, and it must start immediately after the finishing. And it should be continuous without any interruption for at least 7 days. Otherwise, it will be useless. And then the contractor, together with the consultant, maybe they need to select which is the most effective way of curing the concrete on site, and they should utilize that method. So finally, we need to look into the quality and durability as a holistic approach. So if we want to end up with a structure with long service life, with high durability, then it's not the quality of the concrete alone that matters, but also we need to put emphasis on the design, on the workmanship, on the placing, finishing, compaction, curing, and also on the maintenance and the usage of the structure. By doing so, then we can end up with a durable structure with very long service life. Thank you very much. I was going fast. I thought we'll not catch. Yeah.
Partially or what?
All our plants are fully automated.
Fully automatic.
Yes, there are only some left in some plants. Now they are being changed. So very soon we'll not have any manual plants in use. تفضل.
Assalamu alaikum. In the name of Saudi Green Building Council and Saudi Green Concrete Committee, I want to thank Mr. Ridwan Hamid and Saudi Ready Mix for supporting Green Concrete Seminar. I attended more than 6 seminars last 2 years. The only Ready Mix Concrete out of 400 Ready Mix Concrete in Saudi Arabia. They support Green Concrete Seminar with experts from USA, Europe, and Australia, and Iceland. You like slag cement, and I like slag cement. It's reduced heat of hydration. They have bright color, save energy. It will reflect solar radiation. What about curing? They have some crack problem in King Fahd Causeway because they are using slag at that time. In some research, they found if you have 1 week or 2 weeks curing, it's not enough for slag cement, especially if you have 70% slag. Can you comment on that curing, and do you have precaution for some big project you use slag cement?
Yeah, this is what mentioned, that you need to go for minimum of 7 days. The longer you go, it's not only for the cement with the slag, even for normal concrete. If you can go for more than 7 days, then it is more beneficial for the concrete. But this is the minimum requirement from practical point of view. You cannot stop a project for more than like 1 week. So you have to go for other stages of the structure. So at least 7 days. But the more you go with the curing, the more you do. But for the King Fahd Causeway, I think the use of the GGBFS was the very excellent idea, because as you can see until now, it's performing very good with the low maintenance. And I think now for the new causeway, they are considering to go for GGBFS. For the new causeway, which will go just beside the King Fahd Causeway, GGBFS is an option. Yeah, they will do, of course, the proper curing for it. تفضل.
What about the hardness of aggregate you have?
Yeah.
You know, yesterday they were talking about the measurement. How can we measure the hardness of stone, let's call it?
It's not,
Abrasion test, in my opinion, is not the right tool to estimate about the hardness of the,
Since
the stone you are using. In your quarry, two things. Are you using some measures to determine the hardness of the aggregate? Number two, frankly, are you washing your aggregate? Thank you.
Since we are using the ASTM standard, we are following the abrasion test, Los Angeles abrasion test, in order to measure the quality. Because we are using, in some requirements where they are asking for British standard, we can measure the impact value on other tests. But this is seldom used. So we are using the abrasion value in order to measure the aggregate quality. Regarding washing, it depends on how much is the percentage of dust on your aggregate. So if the limits of the dust in your aggregate are within the acceptable limits, then you don't need to wash your aggregates. In some cases where we find, like in some locations in the western region, that the aggregates are rich with dust, silt, and clay, then we need to wash the aggregates. So we have washing plants in some factories, and we wash the aggregates. But in some locations where the aggregates are within the allowable limits, we don't need to wash the aggregate. Yeah. Actually, the water.
All the water here, Saudi, coming from wells, and I'm sure it has chloride, high percentage chloride, sulfide, and TDS. Frankly, are you using special water at a good company and famous company? Special water or ordinary water like any other consumer doing here in Saudi?
All the water which we are using according to the specification. And for your information, the water we are using, like the World Health Organization, they allow for the potable water to have 1,500 total dissolved solids in it. The water which we are using, according to Aramco specification, maximum 500 parts per million. So the water which is used is better even than the potable water according to World Health Organization. In most of our factories, either we have our RO units or we are purchasing water from the companies which they are selling the potable water.
Do you have RO system? Do you have RO, reverse osmotic system for water in your plant?
This is what I'm telling you.
You have it, but it's very expensive, sir.
Yes, but we have it if you visit.
You have it for a special project, not for all.
No, for all. You cannot.
For all.
You cannot get, because we have one big tank in the plant. You cannot have water coming to this project for here or other project. We have an RO unit which will take the water and take it to the tank, and then it will take it to the chiller. So you cannot separate this. You cannot find in a plant even that you are having some material for certain projects and some material for other projects. You have one stock bay, you have one tank, you have one.
Thank you. Thank you very much.
You're welcome.
I will visit your factory. I will visit. I am not sure. You know.
اوكي، اذا الان وقت الاستراحه والصلاه والغداء يعطيكم العافيه، ونشوفكم الساعه 1.
شكرا لك.
معلش البرزنتيشن موجوده هنا؟
حطيتها موجوده. اي
May I have a copy of your presentation?
Yeah, sure.
Oh, you can cancel that. Because you pulled it out, didn't you? Yeah, just hit cancel.
When is, can you give me your interpretation?
I have to.
Can you give me my
Okay, I will give you that one. So actually it will be loaded. انا بدي اشيل هذه اللي هي الباوربوينت بس حاططها انا هنا البي دي اف موجوده بس انا بدي اشيل الباوربوينت.
لازم تقفلها اول شيء.
ممكن هي موجود مفتوحه لسه هي. اوكي 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 هذا موجودة هذه
موجود ايوه بس بنيت
يعطيها
تفضل جزاك الله خير
حياك الله
شكرا لك
This one, huh?
New one, no, we don't.
Kingston?
Maybe, yeah. Right, yes. جزاك الله خير.
حياك. خلاص. ها؟
نقدر قلت لي انا نقدر نوصل؟
لا نسحب بس
ايوه.
لا شو ما نسحب.
ايوه. اوكي. ايوه.
نسوي ازاله.
كينغستون ايوه. Very good. بارك الله فيك. ايوه. Thank you. جزاك الله خير. All presentation we need to take camera, inshallah, to put in my bus. Give me for all presentation from yesterday.
This one?
Yeah.
I think we'll have to.
Open my. Yes, right.
Others we put it in Asasu site.
Yes.
All
Where is the from before yesterday? Before yesterday, the presentation before yesterday. The first one, next day. Okay. Still no, not yet. We don't have. But we need to take. Huh?
Open the desktop
Oh, yeah.
in one folder and take it all.
Oh, yeah, yeah, okay. Okay, how can to please? Please make it here, please. For all. Open for all. Take for all. No, take for all.
Go desktop here.
Yeah. Okay. Take for all.
Maybe
No, this one 64 giga, no problem. You can enter for all.
okay. And put it in. Where is your
The Kingston.
Kingston?
Yeah.
Nice. And that's it.
Okay.
Okay. This 1.5 K. I take it with you in my.
Okay, no problem.
Okay.
No,
This after when you found, you
Yeah.
can delete.
Yeah.
Duplicate.
No problem. No problem. You have business card, please? Can you give me business card, please?
I don't have business card. It's your company or what?
This one you can take this one, business card. Then you can.
Yes.
Yes. Then,
Bilal.
hello. Bilal, oh good. Hello. Can you give me some? Yes, okay. Oh, Dina. Oh, Masya Allah. Yeah, okay. Yeah. Yeah, only yeah. Yes. Next, yeah. Make next. Okay, good. Yeah. Thank you. Jazakumullah khair. Jazakumullah khair. We'll wait for a few minutes. What's your name? Murad. Sudanese, huh?
We're from Sudan.
Sudan, mashallah. Very good. I have Indonesia. We have many friends, Sudanese. All good, mashallah. Oh, yes. I am here in Al-Jumaat 29 years, from 1985. And then we have many friendship for Sudanese. Yeah. But you know, for Egyptian is different. It's different. Some, but most of them is like that.
Not straight.
No. Yeah. But I know the Sudanese, mashallah. Yeah. Maybe this one nature for. Very good.
That is headquarters in Riyadh or?
In Riyadh, yes. You know the Tariq Malik Abdulaziz?
Yeah. King Abdulaziz,
Yes, beside Radisson.
Yes.
There is Al-Jumaat. I am in 6th floor. And about you, where is your office?
Here in, this Oleya.
Oleya, yes, Oleya.
This Saudi Airlines main office.
Saudi Airlines main office.
Near to Azizia Mall.
Azizia Mall. Azizia Mall, this one? No, this one. Azizia Mall is Tahasusi. Azizia Mall.
Azizia Mall here between King Fahd and Oleya.
King Fahd and Oleya. Okay.
This cross.
Yeah.
Imam Saud is Oleya.
Like that. Imam Saud.
Yes, Imam Saud is Oleya.
Yeah.
This cross section.
In the cross, Oleya. Oh, but if I came from the
Malik project here in King Abdullah.
Yeah, no. I went to your office, exactly in Forest Road, okay, and Oleya.
Oh, Imam Saud. Imam Saud, exit 9.
Oh, exit 9.
Yes. Here King Abdullah, straight, and Imam Saud. This is Oleya. This is here in Hayy Muruj.
Hayy Muruj, your office. Yes. Hayy Muruj. Then now 75%, few minutes. Inshallah, go this one for experience.
You have this laptop here or?
I don't have. No problem, anytime you can.
Try now.
I try, okay. Best.
Now you are full data. Now.
Yeah. Good, yes. This one for experience, for study about this one. You are civil engineer?
Civil engineer.
Civil. I am architect.
Architect,
yeah. But my work daily is supervise the project. Yes, supervise. Like consulting. Yeah, like consulting. Consultant office.
Management.
Yeah, like that. To supervise the contractor. Contractor. Another company.
That's just management and supervisor.
Yeah, supervise the contractor like that. All in the kingdom. For you know, we have
not engineering company, Jumeha.
No, there is
holding company.
Yeah. This one holding for all. For all. But special in architect.
Very interesting.
Okay. Huh? Murad. Alas, finish.
Finish, yes. Where is your? This is your phone? Okay. One, huh?
Okay, one.
Okay.
Murad, yeah?
Murad, yes. Saudi Bin Laden, yes. CMA Tower here, Project King Abdullah.
Yeah.
Therefore, you are taking this as a benchmark.
Saudi Bin Laden group, yes.
What your name?
Murad.
Murad.
M-U-R-A-D. M-U-R-A-D. A-D, yes, Murad.
Like that.
Yes, Murad, yeah.
Okay.
Yes.
This one my name. My name is Indonesia.
Indonesia, very nice. This is your mobile number?
Yes.
Okay. Which one? This one?
Yeah.
That means 41 pounds. This is not fully. Which means I have to go
Professional the building. And as description can remain
one company has 400
السلام عليكم ورحمة الله. في الهيئة ولا؟ ادينا الكونتاكت نمبر بتاعك.
وأنا إمام هناك. إمام أنا من بحر التسع. إمام صلاة. ثلاثة وقت بس. مغرب عشاء فجر. الحمد لله.
الإمام هنا في السعودية ولا
في المغرب التسع. في مسجد الهزيمي جورناتا. في تاريخ الملك الوليد عبد الله وخالد بن وليد. سعودي بقى الأمانة. بس على صوت رسالة في زقام. والمفروض هذا موضوع يعني لازم أول يعني مقدمة يعني أي
احنا شباب قبل الاشياء ورشة كلها يمكن اسبوعين، احنا قبل اسبوعين بدأنا الترتيب. قبل اسبوعين ما كان صحيح، بس احنا نقول برنامج خلال اسبوعين يعني كان بسرعة كذا ما رتبنا كويس. كان مرة انت صار
على سبيل الإسلام إندونيسيا هذه في أول مقدمة
في ورشة يوم الأحد في نفس المكان أول شيء القرآن الكريم. ورشتنا هذه ما كنا مرتبين بسرعة كل شيء بسرعة
يعني أحسن كده لو في شيء يبقى sekarang نبذل في شيء إن شاء الله أنا جاهز كده. بقى نصلي إن شاء الله.
حصلتوه كويس. أخذت هذا احنا نبغى نحط عموك على هيئة بس
خلاص
يعني كان بعض النوم يرفض انه يحطها بشكل باوربوينت ما حاولت اني احوله PDF بس ما ادري ما يتحول.
كده احول لك عندك هنا جنب البرنامج
ما يقبل.
لا مش زي بس
في البيت أنا في درس أنا أصلا
خلاص أنا
ini harga walad anak Taufik, anak ismu walad Taufik, anak Taufik. في السلويش ترى. معلومات إندونيسيا كبيرة. إندونيسيا هذا مثلا هذا إندونيسيا 6 ساعات طيران. سيارة طيران ومعلومة البحر 3 ساعات 6 كده سبحان الله.
أول شيء وقت رحنا جاكرتا بعد بس بالسفينة
لازم سفينة
ما في طيارة.
لا طيارة بس طيارة أو سفينة ما في سيارة. يعني
هنا في برنامج اسمه أدوبي بروفيشنال كده ما نازل، إذا كان عندك نازل طوال يتحول.
هو في بس هذا ما
في الجهاز ما في. أنا شيكت في البرنامج.
نحط على موقع الهيئة. أنتم تسووا تصاميم يعني إذا كان مثلا اللي بسوي مثلا ريكاست في مكاتب مساعد تعاون معها مثلا أعمل ريكاست أسرع وأنظر.
هذا سوق نحن يعني أنا شو التصميم في يعني هذه ما في بدون رخصة يعني بدون رخصة مثلا
لازم مكتب.
لازم معك
عشان الرخصة لازم بعد ما يصمم هو تعتبر من مكتب هندسي.
ممكن كمان
هو ممكن يعمل لك
تبع مكتب هندسي.
هي من شركة قابضة هو بس استشاري شغال. لكن مكتب هندسي لازم يعرف الاستشارات. كونسلتنت كمان.
أنت ما عندك مكتب هندسي يعني. أنت شركة
مهندس لازم مهندس كمان.
أي بس ما هو مكتب هندسي هذا شركة قابضة يعني كيف.
لا في مكتب مهندسي. لازم كابل هذا كبير. يعني سكشن يعني ديبارتمنت. أنا 29 سنة سوري ومسؤول كل يوم.
بس ما تعاون مع بريكاست يعني بريكاست.
هذا نحن استشاري يعني.
بدأ فلاش.
أنتوا مع نفسك.
لا تعرفنا بس.
كان واحد أخذه.
أنا في بلادي في بعض في المركز المالي. سوق المال. بس جيران يعني هو ساكن رماط أنا ساكن الحمر.
هو قريب.
يس.
قريب.
إمام سعود.
تعالوا وجدت في المكتب. في بالذات في التقاطع خالد بن وليد. خالد بن وليد.
يس.
ومخرج 9. يسا بعدين مثلا خليج الموارد يمين ممكن 50 متر هذا هو. ولكن أنا سكن الحمام. سكن الحمام. الحمام سكن. لا أنا سكن الحمام فإنسان قريب. بس كل يوم روح هنا.
بس الحمام بيوت قديمة يمكن بيوت قديمة شوي.
الحمام قرب. الحمام قرب. يعني قريب من هذا.
عنده صناعية.
لا بعيد شوية في فوق. ثانية تحت.
الله ثم بعد نشيل. Hello, Mr. How are you? Fine. Good. Everything okay? I need your email to make contact with you.
No problem.
Yeah, your business card or email. Okay, thanks.
جزاكم الله خير. ممكن سلوهين سلام.
Yes. I'm going to come in there. I'm on my way. No power.
Maybe in the
السلام عليكم. ممكن والله ودي أسألكم سؤال كذا، يعني فكرة التواصل عن طريق الإيميل. إحنا الآن لاحظ ما عملنا استبيانات بالمفهوم، وكان ودنا نعمل الأشياء دي، بس إنه جلست فكرت فيها البارح إنه من خلال يعني الحمد لله ما دام الآن في تواصل وعندنا عارفين كل المعلومات وحضرت من الورشة دي، فإنه من خلال الإيميل بنرسل لكم الأشياء ممكن نتواصل. هل ترحبوا بهالفكرة؟ لا ما ابغى تعبي اي ورقه، انا ابغى الواحد يفكر في الاشياء. يعني احنا بنحط مواضيع محدده نسال عنها، مواضيع عامه مثل موضوع الترجمه لكن في اشياء تتعلق بالتكنيكال الى حد ما، تتعلق بالمواصفات. ايش رايكم في كذا وكذا، يعني من القضايا اللي اثيرت من خلال المحاضرات. فهل هذه معقول يعني انه طيب لا هي في، بس انا يعني يمكن مؤقتا لان لسه ما تفعلت كل الاشياء، حستخدم الايميل بالطريقه خلينا نقول بنحاول نرسل نموذج وفيها كذا وتردوا علينا فيه. ريت بارك الله فيكم. نعم نعم موجود، بس انه انا قصدي الاستفسار تكنيكال يعني لا يعني هذاك الموجود الان اذا حد عنده رساله كنا الهدف تسجيل، هذيك ما حاعتمد عليها لغرض لكن نعم صحيح. لا انا يعني قصدي مؤقتا لانه ما عملنا النموذج المعتاد للاستفسارات ولأخذ الراي، فبنحاول ناخذ رايكم من خلال البريد الالكتروني يعني في المواضيع المتعلقه بالورشه. شكرا.
Okay. So I'm going to finish up today with this last presentation on sustainability. As I was just explaining before I came up here, I've spent the last 10 years working with sustainability initiatives. And from a history standpoint, in the States, it's really only been in the last 10 years where we've seen a pretty big shift in concrete technology with sustainability. Now, there have been other initiatives. The U.S. Green Building Council was mentioned and those type of issues, but this is something that right now in the United States, there's a history that shows that we, by 2030, by the year 2030, up to 50%, 50% of commercial construction in the United States will be green building or sustainable design or a connection to. By 2030, 50% of commercial construction will be green building or sustainable design. That's a huge number for us. So these are some of the things and experiences that I've had in sustainability and some of the things that have challenged us in the engineering community when it comes to those. But before I get to that, I have to make some distinctions here. We have to start with some definitions because, as I alluded to before, if I asked everybody in the room to write down their definitions of sustainability, we would, and there was 50 people in the room, we'd have 53 definitions. It's not very clean because we all have our own ideas of what it is. And the other thing is, because it came out so fast and it came upon us so quickly, we didn't have a chance to analyze or think about it. Because as an engineer, as a technical community, we want to test something, we want to measure it, we want to give a value to it, we want to put a metric on it. This is not that way. The other thing that, and with sustainability, is companies are struggling with this. Certain agencies are struggling with this, and here's why. If you work in a company and you have a sales problem, you give it to the salespeople. If you have a technical problem, you give it to the quality people or the engineers. If you have a production problem, you give it to the manager who runs the plant. If you have an accounting problem, you give it to the accounting or administrative staff. But sustainability is one of those things that it doesn't have a very nice, neat hole to put something in. Because it is technical, but it's also production, but it's also administration, and it's also sales. So we're struggling with that, so we've had to kind of step back a little bit and start to define some things. So here's the way I'm going to look at it today, particularly with respect to concrete. So there are products, and there is a process. Now, we just finished talking about sustainable plants and processes there. I'm not going to talk about that here this afternoon. I'm not going to address process. I'm going to address product. That's all I'm going to focus on is product. But I think it's very important that we have to look at a philosophy of sustainable design. What does that really mean? Because once we understand that, then we can begin to back in and see how these products fit into that. So here's the easiest way that I have been able to make sense of sustainability. Sustainability is a design requirement exceeding the design function over time. That is sustainable. It's the easiest and simplest way I can sort it out in my head. Now, the design requirement is a specified level of performance, and the design function is the specified intent. Design, performance, design, intent. So in this particular case, my design requirement is the performance basis. So if I make a simple substitution, I get performance exceeding function over time, and I have something that's sustainable. Performance exceeds function over time. But let's kind of further define something. Performance, expected result from the design as measured, keyword measured, by a standard method. Now, if I was trying to find a standard method, where would I go? Test methods, standard specifications. Function is that intended use. So as long as the performance exceeds the function, over time, I'm sustainable. Everybody with me? Everybody okay? Okay. Now, here's something else that happened. As we've been talking about sustainability of a product, sustainability of a system, something else happened during the last 10 years. And this has really been in the last 3 to 5 years, is this other word has come up. The word is resilience. Resilient building, resilient design, resilient construction. Where did that come from? Well, hang in there. Let's go back up here. Resilience, ability to recover or survive from difficult and or negative conditions. Simple definition of resilience. Now, why is that important when it comes to construction? Why is that important? Well, in this particular case, design exceeding function plus these negative conditions. Well, what's a negative condition in construction? Or in a constructed building? Wind, flood, fire, hurricane, seismic issues. Those are difficult conditions. Now, we have had our fair share of natural tragedies in the States, from tornadoes to hurricanes to floods. And all of a sudden, that started people thinking about what this means for construction. What is a resilient home? What is a resilient hospital? And so in this particular case, It's that design, that performance exceeding the function with the negative conditions being factored in. If you were going to design in a coastal region, you would not only be designing the material to survive, say, exposure to seawater or salt or humidity, but what about wind loading? What about wave loading? What about flooding? What does that mean to design that way? So here's my resilient definition of resilience. So now I've got these things. I've got a performance as measured. I've got my intended use, and I have my negative conditions, all that I have to factor in to create this resilience. Now, here's where it gets complicated. So if everybody's followed me up to here, this is where we get into a little bit of a challenge, because our design philosophy when it comes to concrete design, not talking about just the mixed design, I'm talking about everything from the structural design all the way to the mixed proportioning. Because if some of you have ever taken a structural concrete class or thought about structural concrete design, as concrete designers, we don't take much into account anything having to do with the mixed design. All we want is the strength for the calculations of loads. That's how we approach it. But in this particular case, I've got to think about some of these other things, because the prescriptive approach is very much rooted in what's taught in universities. It's very much supported by the codes and standards we were just talking about earlier. ACI 211, we were looking up, somebody had a question about where I got the water content from. And it was a chart where we went across based on the aggregate size, came across based on the slump, and it gave us a prescribed water content. Just said, this is what your water content will be. Well, how did you know what the shape of the aggregate was? Was it crushed? Was it gravel? And how can one water content give me a slump range of 3 to 4 inches based on one aggregate size? It was a prescribed part of it. The other thing is, when we look at prescriptive elements, it doesn't force us to exercise any judgment. It doesn't force us to exercise judgment. It's very objective, meaning you just pick the numbers and you plug them in and you say, this is what we'll do. And here's the other one for us. We look at this as, there's a perception that this prescriptive approach reduces liability. Now, why am I spending all this time talking about prescription versus performance? Because this doesn't seem to fit. Well, when we go back to this, it does. Because from a sustainability standpoint, does the traditional design approach create an inherent conflict with the resilient or sustainable design? The question is, can you prescribe sustainability or resiliency? Can you prescribe sustainability or resiliency? Because according to this, it doesn't look like it, but we're going to force fit this right here. So instead of performance, imagine if I put in prescription, prescribed there. Could you prescribe sustainability? Well, let's talk about that as we go forward here. This is my quick little slide that right now sustainability was the big one. Now we're already talking about resiliency. Right now I don't even think about somebody saying, oh, can you make us a mixed design that has sustainable concrete? When we go out and we sell a job that talks about sustainable concrete, we're talking about resilient concrete now. We've moved past sustainability. We're already into resiliency now. That's how quickly things are moving and progressing. So, I'm giving you two comparison charts here, or two columns. Look at the traditional design criteria that we would think about when it comes to a concrete design. When we want to proportion it, or we've got somebody who's looking to use it. I talk about slump, I talk about maximum aggregate size, water content, air content, water cement ratio, coarse aggregate content, fine aggregate content. Standard things you would expect to see in a mixed design or somebody would ask for in the field. Nothing out of the ordinary there. None of those are bad either. They're all just part of a traditional design approach. Look at the right-hand side of the chart. Look at now what we're being asked for in the mixed designs. Recycled content rate, emissions footprint, survivability, durability, cost. And I'll talk about this EPD here in a second, Environmental Product Declaration. Notice what's also not on that list. Anybody see anything in there that talked about anything over here? Now, it doesn't mean they're not part of this list, but these are some of the first things that are asked for. This is the list of things that are asked for first in a concrete mix design now. This is the list of things that people are asking for first. Tell me what the carbon footprint is on your yard of concrete or your meter of concrete. Well, don't you want to know how much cement I'm putting in it? No, I need to know about what your carbon footprint is first. Well, do you need to know what the slump of it is? I need to know what your emissions footprint is on that yard of concrete because we're trying to build a building that has the lowest emissions footprint during construction. Do you want to know what the air content is or how much aggregate I'm using? No, but I'd really like to know what the life cycle cost is. First cost is what you pay per yard. Life cycle cost, we'll talk about that. These are the questions that are coming. Now, imagine that you're in the sales department and your customer comes to you and starts asking those questions of your sales team. Imagine you're sitting somewhere and you see that they're about to build a new tower somewhere and you hear the term, they're going to do it according to a green building or resilient building standard taken from Europe or the US or somewhere. Are you ready to supply the concrete to that because of these questions? We'll keep going. All right. So, codes or generally accepted design methods approach things like this. Now, I'm not saying these are bad by any stretch of the imagination. Don't get me wrong. These are not negatives. This is just a traditional way by which we have designed concrete. We've talked and seen many of these in the last 3 days. But none of these are performance-based. They're metrics. They are things that we want to measure in a proportional mix design. They can be linked to, they can be related to certain performance characteristics, but they are not a performance measurement like some of these other things. So, I'm going to give you some examples here of some things that 10 years ago I would have said were non-traditional concrete. Non-traditional concrete. That by now, my experience, these are very common concretes. And some of you may know of some other concretes that are being done around the world that 10 years ago would have been considered non-traditional concretes that today are very common where you're working. So the first is something called HVFA, high volume fly ash. We've talked about pozzolanic replacement. Some of you have even done this before in some of the markets you're in. But your common replacement values may have been 20%, 30% of powder replacement, maybe a combination of GGBFS in combination with silica fume and those things, and you came up with a 40% or a 50% replacement. What's happened was somebody said if 10% was good, why not 20%? We go into 30%. We talked about that. Well, we kind of stopped at about 30% fly ash replacement. Well, why did we go past that with respect to green building, sustainable design, resilient design? What was the driver? It's recycled content rate. Recycled rate drove us to that. When the first questions came out about concrete and our use of recycled materials, the first place we went to was fly ash. Because it was a waste product and we started putting it in there and we could increase our percent of recycled content rate. Now, anybody doing the math in their head on this one? An average standard concrete mix design contains X amount of pounds of powder, kilograms of cement. Do a 30% replacement. And you're thinking, oh, I've got a 30% recycled content rate. No, you do not. What is the total weight of the meter of concrete. Now take that, take your fly ash and divide that by the total meter of concrete weight, and now tell me what your recycled content rate is. At first, we got really excited because we said we're recycling a lot of material. On a percentage basis, we doubled the amount, but on an overall percentage, it moved 1%. So it really isn't that much. The challenge, I'll get back to how we increased that number here in a second. The challenge was getting people to accept this. Because you remember the chart that I showed a couple of days ago about changes in strength gain, changes in setting time. Well, what happens if I keep putting more and more fly ash in things? Setting time and strength gain are both impacted. Not in the positive, because we want things to set faster and gain strength faster. Well, now wait a second. If I start using more fly ash, I might be able to use it in different applications. But it was a mindset. It was the way people were thinking about using the fly ash. The same way that many of you who have used GGBFS have had to convince somebody who said, we don't want to use that, we just want cement only. So in this particular case, what we had to do is we actually had to show equal set time, equal strength gain. And here was the other challenge for the companies that went this direction. We were talking about, in the last couple of days, I've had several conversations with people who are talking about, well, we've used the phrase in here, you've heard me use it, tell me how you want the soup to taste, don't tell me what to put in it. What happens if I won't show you what I put in it? Because I say the design is proprietary. I invested the time to create this new product, this new material. Anybody in here familiar with a company named Lafarge? Anybody ever dealt with Lafarge? Global company. They came out with a self-compacting, self-leveling product called Agilia. Anybody familiar with that one? You could buy it around the world, but you could not know what was in it. They sent it to you in a giant bag, and you added water to it, and it just worked. I bought 2 bags of it because I wanted to find out what it was. But they would never tell you what was in it. They said it was proprietary. Now imagine as an engineering community where we're so used to seeing the proportions and seeing what's in there, and all of a sudden somebody says you can't see anymore because I've engineered a new sustainable or resilient material, and I can't show you. I'll tell you how strong it is. I'll tell you what the carbon footprint is. I'll tell you all these other things, but I'm not going to tell you how I did it. I'll give you each material certification, but I won't give you the proportions. Imagine how we as an engineering community would react when somebody said, no, you can't see what's in it. Now, I found it interesting. In the presentation before me, there was a line in there about how the improvement of durability of concrete increases with a decrease in permeability. I gave that similar statement, but it was there. For so long, in the concrete world, we thought about concrete of making it more impervious, lower permeability. What happens if we go the other direction? What happens if I make it highly pervious? In fact, I'm going to make it porous so water flows through it. It can still support a load. Now, I'm not talking about something structural. I'm not going to build a building out of this. But what if all of my pavements or certain pavement surfaces, when it did rain, because we want that water to go back into the ground faster, or I have the ability to capture it faster, as opposed to running off, going down into a storm drain, into a sewer, where it's got to go somewhere and then be processed. What happens if we actually let the water run through the concrete? And all of a sudden, this became a huge component in sustainable design and construction, is pervious concrete. How do you actually make that? I've made this several times in the back of a truck, but it is a true concrete that is 180 degrees opposite of the way we've thought about concrete traditionally. We want water to flow through it. We want water to flow through it quickly. Now, think about that from a design perspective. Previously, we only had to concern ourselves from a design perspective with the concrete layer. We didn't really care so much about below it, the sub-base or anything else, as long as it was strong enough to support the layer above it. Now, not only does the layer below have to support the layer above from a strength standpoint, but now it has to manage the water that goes into it. So now all of a sudden I've got other things involved. I can't just show up with a concrete like this. And because if you'll notice here, 2,000 to 4,000 PSI. We're driving on this stuff. This is parking lots. These are our roads. These are streets. These are very common, you would see in certain areas. Now, the other thing that we discovered, anybody ever have to supply material or heard of something called a water detention pond or retention pond, or been involved with a development that said you must have a detention pond on site? What we discovered was we could store water in one of these, and you could park on it. It actually has enough volume in there that water can be stored, and you can park on it. Now imagine trying to tell the current engineering community about something like that. This is a real challenge for us because this is vastly different than what we're used to seeing. Now, reflective pavements. Now, this is a touchy subject for concrete manufacturers who are also in the aggregate business, because this gets into an argument of what we call the black versus white argument. Concrete versus asphalt. Now, I don't have to, I think, tell anybody in here about something called a heat island effect. When the sun beats down on a developed community, light versus dark, one stores the heat more than the other one. It reflects. So if you have a bunch of asphalt pavement, you can have stored energy, heat, that doesn't dissipate as fast as something that is a light-colored pavement. We discovered this in something called reflective concrete or cool pavements. What it really came out to was we just paved out of concrete instead of asphalt. We actually were able to lower temperatures in the surrounding communities by nothing other than changing the pavement type. The parking lots. And we were able to lower the temperature. Now, why is lowering the temperature so important? Well, not just because we want to feel comfortable, but if we lower the ambient temperature, we also reduce the energy consumption of the surrounding buildings. Because if the temperature is lower, the demands on the energy systems on the buildings to cool them also drops. There's been several research papers that have found that to be true as well. Effectively, by changing the material in the streets, roads, and pavements, we change the energy consumption in the community just by making one material choice difference. Again, something 10 years ago we would have never thought about. We would have never considered that the concrete or the material choice for the pavements or roads was somehow connected to the energy consumption within the community. We just didn't think that way. So now all of a sudden you're starting to see this pop up, and somebody says, with any metric, well, how much light does it reflect? Well, luckily we had a test method. ASTM C1549. Now, the question, this comes up similar to the shrinkage test. Somebody says, I want my concrete to be reflective. I want it to meet this albedo, called an SRI, Solar Reflective Index. Do you want it to be that way? Do you want that at day 28, day 56, 1 year? Imagine you've got a specification that comes out that says we want the concrete to be 30 MPa at 28 days, and we want to make sure that it's still 30 MPa at 1 year later. Anybody ever seen anything like that? Anybody ever heard of anything like that for strength? I haven't seen anything like that. But now we have specifications that say we want the reflective index, the albedo, to be 0.4 at day 56, and we have what's called a sunset provision that says we're going to come back and measure it 1 year later and make sure that it's still at that reflective index. You're telling me I'm responsible for the concrete 1 year from now, after it's met strength? No. You're responsible for its reflective index 1 year after it's met its initial reflective index. We don't think that way. We hadn't thought that way 10 years ago. But now the specifications are beginning to ask for this. Now the other thing is, as a producer, as somebody that's had to do this, anybody have their albedo rating? Anybody have their solar reflective index rating in their database of history on their concrete mix designs? No. We had to go test it. Do you test it in the laboratory? Well, we did that the first time. Then we made that mistake, and we said, no, we want to go out to the job site. We want to go with the finishers. I want you to do a test panel out here. I want you to finish it the way you're going to finish it, with the guys you're going to finish it with, and then I'm going to take a sample out of that. Because the solar reflective index is a measurement of quality, or it's a measurement of the concrete in the field. So we want to put it under the field conditions. Now, here's the other part. If anybody wants to get into the measurement business of solar reflective index, I would highly encourage you to, because it's highly lucrative. In the U.S. right now, there are 4 testing labs that do that. That's it in the entire country, 4. One of them is a university. So there's 3 commercial labs that do it. 3 labs in the entire country. When I heard that, I said, oh, that's going to be expensive. That's going to be very expensive. It's about $3,000 for one test, and it takes anywhere between 3 to 6 weeks to get a result back. That's not because the test takes that long. It's because that's how many people they have in line in front of me. Machine costs about $10,000 to buy. So if anybody's interested in getting into that business, it might be highly lucrative for you. All right. Self-compacting concrete. You saw some videos of this earlier and this happening. So, and you've heard some descriptions of it in conversation. But here's why it's so important to this conversation we're having right now. So, if that video was running, a couple of things. When I first came out to this job site, we didn't tell them that we were coming with self-compacting concrete. We had already talked to the owner, and they were fine with it. But we didn't tell the tradesmen that were out there that we were coming up, because we wanted to see their reaction. We wanted to see what choices were made on the job site. A couple of things. So first, this is the end of my chute right here. This is the self-compacting concrete. You can see it's run over the edges. You can see the aggregate is still there and it hasn't fallen out or segregated. Now, you see the feet right here? You see the feet right there? Those are the feet of the laborers out there who would normally expect to take their what we call a come-along. They put it in the concrete and they pulled it there. Do you see them in an active position at that point? They're standing there. They're standing there. Now, the other thing that is not present on this job site, was present on the job site, but not in action, was the pump. There's no concrete pump here. Now, a couple of the guys I don't need to be as active anymore. From a commercial standpoint, what does that mean? That means I may have extra labor out there I don't need. If I don't have a pump out there, what does that mean? That means that there's an extra expense out there I don't have as well. That's good. I've saved some money there. But now how does that relate to sustainable? If I don't have a pump out there, what else don't I have out there? If the pump is not there, the concrete pump truck, what else isn't there? Vibration. What are we concerned? What are one of the things we're concerned about with sustainability? Emissions. What runs a concrete pump truck? Big diesel engine. All of a sudden, the emissions from a piece of equipment are not present on the job site anymore. I have the same number of trucks that are there, but guess what happens? I can unload one of these trucks in about 3 to 6 minutes. If I was into the back of a pump truck and tailgating at a regular slump, it may take 15 minutes. I can get a truck off the job site faster. Does that mean I have now contributed lower emissions? Yes. I don't have a pump truck on the job site. Do I now have lower emissions? Yes. You're telling me that I can design a concrete and have it show up, and the choice of the concrete I make can lower the emissions in a community because of the choice of concrete. Yes. That is not how we thought about concrete 10 years ago. In fact, some people still don't think about concrete that way. Imagine if you're an engineer, or imagine going into that engineer and having a conversation with them saying, I would like you to think differently about concrete because here's the self-compacting concrete I have, and I'd like to place it there because it lowers the emissions in the community. Well, what's the slump of the concrete? Well, it doesn't have a slump. It's flowing. Well, I'm used to seeing concrete with a slump between 100 and 140 millimeters. Well, but it's 200 millimeters. Well, but I need concrete that's a slump between 100 and 140 millimeters. We don't think about concrete that way. Now, all of a sudden, I have a concrete choice. I have a concrete material that impacts the community. Now, of course, I like this one right here. It's not a new concrete. That's always the biggest thing is somebody asks, and it's like, well, we're going to need a bunch of backup data on that concrete. Concrete doesn't have a memory once it gets hard. It doesn't remember what it used to be. If I take a section out of this concrete here, I can tell you how strong it is, but I couldn't tell you what the slump is when it was placed. It doesn't remember what it used to be once it gets hard. Recycled water and stormwater. We've talked about this several times, how we had to come up with our own standard, how we shape concrete plants, those kind of things. The potable or potable water standard, if you could drink it, you could use it in concrete, but if you couldn't drink it, you could not. This was the other difficult thing we had. Not only did we have to get the standard to agree with us, we had to make sure that we wrote the standard the right way, but then we still had to go speak to the engineering community about this. Now imagine being able to go in and look at your concrete over an annual basis. An annual basis. You can calculate how many meters you used. You can calculate how many liters of water you consumed. Remember that percentage equation I showed you up there earlier about your recycled rate? Your waste reduction rate? Imagine doing that same percentage on amount of fresh water consumed. 100%? 50%? 40%? Because you used other water sources. We didn't think about concrete that same way. We just didn't. It had to be drinkable to be usable. All right. I want to talk about some issues and challenges, and I've been alluding to these. And I'm going to talk about several groups here. So the first was with the engineering community. So I got to do this because I'm an engineer, and so I got to kind of make fun of my own profession a little bit here in our reluctance to accept things. My experience has been the one thing you can't tell an engineer is that they don't know something. And in our community, it was one of these aspects that there were different products being developed, being designed, not by the engineering community, but by the ready-mix community, by the materials community, by the research community. We were coming up with these great solutions, and we were shouting upwards going, we've got answers down here to problems. But we had trouble getting them to accept them, to understand them, partially because of some of those other issues about codes. The other thing was this whole aspect, and you've heard me use the term twice, explicit versus implicit. Being able to explicitly say what you want the concrete to do versus assuming what it should be. I had a wonderful discussion down here during the break with someone who wanted to continue talking about the 75% of the strength gained in 7 days, about where that came from, where that, how that developed and originated. And I showed you, we discovered it. We went back to the original research paper of how it got inserted in 1953, 52 into the ACI code. And then it became part of academia, it became into books, it became into the contracting world. But the truth of the matter was, that's an implicit assumption. That's an implicit behavior that we expect out of concrete. My thing would be, do you want an explicit? Tell me what you want. For the engineering community, when it comes to green building and resiliency, go back to the definition. It's performance-based. As an engineering community, we have to focus on the performance aspects that we want. As a material supply industry, we have to be able to deliver that performance. All right, architects. Architects. You saw, I think it was Chris, yesterday, talk about this replication of specifications, and we're really good at taking the bad parts and keep repeating them. My experience has been with architects is many times they don't understand their own specifications because they are not the technical experts in that. The scientists, the engineers, the material suppliers really are much better, have much better expertise in material technology than the architects do. That doesn't mean all of them. But in a lot of cases, their material experience is rarely based on success. It's typically based on the last time they had a problem, and that way they can know what to avoid. And in many cases, with new technologies, it's always easier to say no than yes. So in a lot of cases, the easiest way I have found to navigate that is cost awareness. But here's the other thing is, you remember I mentioned the term first cost versus life cycle cost. Now all of a sudden, the architecture community has awakened to life cycle cost. They're now beginning to appreciate and understand life cycle cost for a structure. I'm going to show you here in a little bit where that's going. Contractors. My experience with this one is any change is a bad change, particularly when it comes to differences in placing and differences in finishing. Think about some of those concretes I showed you. Self-compacting concrete, pervious concrete, high-volume fly ash concrete. Those place differently, they finish differently. Most contractors like to see concrete the same way that they saw it yesterday. And they don't like deviations or differences in that because they've got one crew, they've got one set of equipment, and they're typically used to that. Those of you that have supplied concrete that is, we're going to call it out of normal, out of the ordinary, have probably dealt with more sophisticated contractors who know how to manage or deal with that. Some of you may have tried new products with them where you had to give them a test panel, a trial panel. You had to practice with them. The other thing is, contractors don't speak the same language that engineers do and that material suppliers do. They have something, the way that they price something out, whether it's dollars per hour per square foot, dollars per square foot, dollars per hour. They look at things differently because it's not just one unit of concrete. If one unit of concrete, meter or cubic yard, sells for $100, that's not what it costs them. They buy it for $100, but it costs them an additional $50 to install it. So they look at that unit of concrete, it's $150. Now, let me ask you a question from a contracting standpoint. I'm going to sell you, your ordinary yard of concrete costs you $100. I'm going to sell you a yard of concrete for $106, but it will save you $7 on your installation. Did you make money? You have a chance to buy $100, a unit of concrete for $100, or I'm going to sell you another unit of concrete for $106, but it will save you $7 per yard to install. Which one would you buy? All of us in here would buy the second one because we saved ourselves $1 per yard. Now, how many contractors do you think will get to that point because all they're going to see is $6 more? It's too expensive. It's too expensive. Too expensive. Ever seen that happen? That's how we thought about concrete. Now all of a sudden we are thinking about concrete not just as a discrete purchased product, but as a product that has to be installed and placed into the structure, and the cost of that factors back in. We didn't used to think about concrete that way. Now we are. All right, testing labs. Testing labs. So, testing labs, this is the challenge when it comes to testing labs. Imagine I showed up with self-compacting concrete, you've seen the videos, to a testing lab. My friend here works for a testing lab, and I didn't tell him I was coming with that. Remember the reaction that you felt when you saw it the first time? Imagine you were a technician out there that was going to make cubes out of that concrete. You'd be on the phone calling somebody. There's a problem with the concrete. How do you sample that concrete? How do you make a cylinder out of that concrete? You scoop it up, I guess, tap it. If the testing labs are not engaged as a part of this exercise, you now have a problem. They have to be included very early on with the supply of this. The other part about this is the assumptions. Remember the assumption about the concrete, the self-compacting concrete? It's got too much water in it, it's too wet. That's an assumption based on historical experience. Some of those don't apply anymore. Imagine I showed up with the pervious concrete that lets water run through that. How do you sample that? How do you make a cylinder of that? How do you sample its porosity that lets water flow through it? When do you do that? Testing lab has to be included early in this process. We have to communicate better. Okay, so that's kind of where we are with this whole aspect of sustainability and resiliency. Well, remember I said we went from sustainability to resiliency, and then now we're to this next step. And this next step is something called environmental product declarations. Anybody in here, by show of hands, anybody in here familiar with something called EPD, environmental product declarations? One. Okay. Well, the good news is this will help because this is coming. This is the way we are going to construct things out of concrete. Maybe not tomorrow in your market, maybe not next year. But if you are going to continue to work in a global environment, connected to the global community, you will see this turn up more and more. I cannot encourage or stress to you enough that if you see something in a trade journal, a magazine, or some type of publication that talks about environmental product declaration, EPD, read the article. Get familiar with this. This is not a, you'll have to help me with the translation, a passing fad. This is not something that will be here for a couple of years and go away. This is how we are going to construct things. All right, so I'm an engineer. You know that now. I like to work backwards from the answer. So when it comes to this, I have to work backwards from the answer a little bit. So in this particular case, where we're really trying to go is something called the life cycle cost analysis. That's ultimately where we're trying to get to. The EPD gets us there, and I get data and this PCR to get us to here. A lot of letters. Let's simplify that a little bit. Here is what these two things are. Life cycle assessment. Investigation and evaluation of the environmental impacts of a product, process, or service. In our particular case, we're two of those three. We're a product that's a function of a process. Life cycle assessment. Life cycle cost assessment. The exact same thing, taking into account acquisition, construction, and maintenance costs. First cost versus life cycle cost. The best example I can give somebody on what that means is, I want to go pave 1 kilometer of road out in front of Sasso. I want 1 kilometer of road. Somebody says it's going to cost X. That's what we would call first cost. That's what it costs. Life cycle cost is, what is it going to cost me for the next 20 years to maintain that mile of road? So I have the first cost, and then I have a certain cost every year to maintain. And then I compare that to another product. Let's say I build it out of asphalt. There's a cost, first cost, then there's a life cycle cost. Let's say I build it out of gravel. There's a first cost and a life cycle cost. You could compare those three together. What we have as a community been thinking about was first cost. So I want to know, first cost, first cost, first cost. What is the least amount of first cost I can pay? And then we never thought about the life cycle cost. Have any of you ever been somewhere where they built a brand new road, and then in several years, not 20 years, several years, the road caught what we like to call orange barrel disease? Anybody familiar with orange barrel disease? It's the barrels that block a lane because they're repairing a lane. It's what we call orange barrel disease. And we ask ourselves, how did that new road catch that disease? It's a brand new road. Because they're doing maintenance on it. Now, living here, or being here the last several days, would any of you be concerned about how much the road cost or how much time you spend in traffic? Now, would you rather pay more for a road to spend less time in traffic? Or would you rather pay less for a road to spend more time in traffic? Does anybody like to spend more time in traffic? Anybody? Nobody does. So, this is life cycle cost. This is the reality of life cycle cost. Wait a second. Are you telling me that if I buy a different material, I could spend less time in traffic? Yes. Less traffic means what? Less emissions. These things are all beginning to be connected. We're doing a much better job of drawing connections between certain things, of material choices to community lifestyle, to community improvement. Okay, so that's life cycle cost analysis, right? That's where we want to get to. The evaluation of environmental impacts of a product process based on those. Well, how do we get to there? How do we get to life cycle cost? Well, the first thing we need is this EPD, Environmental Product Declaration. Reports produced by product manufacturer that gives comparable information regarding the environmental performance of the product. Comparable information regarding the environmental performance of the product. Now, I can't mention something called an EPD without mentioning the product category rule. The product category rule is guidance for how the calculation should be done and how this information should be presented. Now, that's a lot of words, that's a lot of language. What does that really mean to me? This is the simplest way I can describe it. It's a nutrition label. It's a nutrition label for your product. The PCR describes the shape, what goes on it, what I'm measuring, those type of things. It's the format. The EPD gives me the numbers that go in there. Have any of you, now, I'm a little bit heavier than I normally would be, and so my wife likes me to watch what I eat. So when I go to the store, I have to compare this product to this product. This got so many sugars in it. This got so many sugars. This got so many grams of fat. This has so many grams of fat, and compare them. And I got to get the one with the least amount of fat and the least amount of sugars. Anybody ever done that? Anybody been in that situation? Yeah. So, we're already doing it. We just didn't know it. And now all of a sudden, imagine having 2 meters of concrete. He produces concrete, 1 cubic meter. I produce concrete, 1 cubic meter. And I have the nutrition label for each one. Not what's in it in terms of how many pounds of this or pounds of that, but how many kilograms of carbon each one is responsible for. How many kilograms per BTU, meaning how much energy it takes to make that meter of concrete, and we compare them together, and I can go to the person and say, here you go, here's how you compare them. I want the one that has the least amount of carbon in it. What was the slump? This is how we make the comparison now. Remember the old thing, you compare a mixed design? What'd you look at? Well, this one's stronger than the other one. That's about it. Now all of a sudden we're comparing completely different criteria, and we have to have these documents to do it. Now, so EPD populates the PCR. The PCR sets the rules. This is where it gets interesting. Now, I give you this collection of people that have developed PCRs. The first is, there are a couple of global places you can actually go get one of these. Global PCR for Concrete, Cement Sustainability Initiative. The EU PCR, Building PCR Standard. ISO has a global EPD as well. So these already exist on a global basis. Now, they already have set those rules. Now, are the rules the same? No, they are not. Because they take into account regional issues. Now, I'll give you a great example. So, PCR for concrete, right here. So, 3 years ago, a group of people got together, and I'm not kidding you. It was not a government agency. It was a group of people. A couple of architects, a couple of engineers, a couple of consultants, a couple of producers, probably no more than this group of people right here. They got together and they said, we're going to be the Carbon Leadership Forum. That's what they named themselves. They named themselves the Carbon Leadership Forum, and they said, we need to develop the North American Product Category Rule, the PCR, for North America. Because we're a little bit different than the Europeans. We don't have some of the same issues that they do. We're a little bit different than the global one from ISO, so they developed their own. They took what they could from ISO and the global PCR for concrete, and it just said, this is it. So, anybody have a competing one? Nobody did. It became the North American PCR. Well, all of a sudden ASTM says, we want to develop a PCR. So, could you have 2 PCRs in the same North America? Well, what they've done is they've said they wanted to, and remember this word, I'm not sure if it will translate, but the word is harmonize. They wanted to harmonize their standard document, which meant this group had to talk to this group. And guess who was the guy that was on both of those groups? I sat on the Carbon Leadership Forum, and I sat at ASTM, and they said, Rich, Can you help harmonize these two documents for us? So I worked with both groups, and we now still have one PCR for the North America. ASTM has finalized theirs, and it's now the same as the other one. So we now have one set of rules for developing the EPD. Now, does this mean that these rules are secret? No. They are open, they are transparent, and they are available to anyone for free. Anyone can see access to them. Now, this is the other term to be aware of, something called a program operator. Program operator defines product categories for open consultants, selection of competent verifiers to maintain a transparent and available library of EPDs. What does that mean? So, what that means is, now I have my meter of concrete, I have my kilogram of aggregate, I have my kilogram of cement, and I would like to get an EPD, Environmental Product Declaration, for that product. Where do I go get it? You have to find a program operator, and the program operator takes the information in, evaluates it, and then issues you your Environmental Product Declaration for that. Now, by the show of hands I saw earlier, some of you weren't familiar with that. There are 5, as of this day that I'm aware of, 5 EPDs have been issued in the United States in the last 12 months to ready-mix companies. 5. Last year, in 2013, it was 0. In 2015, we expect there to be 50. Now, those are mixed designs per plant, not 5 mixed designs, 5 environmental product declarations. The first one has 4,000 mixed designs in it for all of their plants. Some of them have 20 or 30. For each mixed design, it has its own nutrition label, its own environmental product declaration. This takes a tremendous amount of data and input to go to the program operator who issues it. Now, notice the last sentence there. Maintain a transparent and available library. Right now, any one of you could take your smartphone, go to Google, and type in U.S. Concrete Environmental Product Declaration. Do that. Not now. Wait till I'm finished speaking. Do that here tonight, on your way home, somewhere else. Type that in and look at the document that comes up. You can go to the NRMCA website right now and you can find all of the EPDs that have been done in the U.S. Now, that's great. You can have access to that. Wonderful. Guess what else that means? It's now transparent that everyone can see. Because guess what's also listed in the EPDs? The mixed designs. I can tell you how somebody's producing. I can tell you how many kilograms, how many liters, and how much admixture they're using in their mixed designs. It's transparent and open. For any of you that are looking for your next big idea, figure out how I can do this online. Figure out how I can enter my mixed design online. I'll tell you who my material supplier is. I'll tell you what the mixed design is. And figure out how I hit the submit button after I've entered my credit card data. Hit the submit button, and I can get my EPD back in the form of a PDF that I can email to my customer and do that entirely online. Right now, there are people working on that because they are databasing cements, fly ashes, aggregates, sands, admixtures, not just in the U.S., from around the world, so that if anybody wants to enter, depending on where you are, you can. Oh. Who's currently doing this? Are there any requirements to become a program operator? No, there are not. I have often said that if anybody wants to join the rich consulting firm We're going to work in a global capacity to be a program operator to issue EPDs. The first environmental product declaration that I was aware of in the United States that was done, the cost was somewhere between $40,000 and $50,000. Now the price is down between $3,000 to $5,000. That's a lot of money for a ready-mix company. It'll keep coming down as the competition goes up, as the technology improves and the speed improves. But right now, there's only 3 places you can go in the U.S. to do this. I already talked about the information being shared on the internet there. Okay. So where's this going to show up first? So this is kind of my description of how a construction project goes with an owner to an architect to an engineer. They create these contract documents. They hire a general contractor. And this kind of forms the top. Then beneath that, you have the subcontractors that support. Yes, sir. Yes. I'm going to pause here for a second. We have some honored guests that we'd like to introduce.
السلام عليكم ورحمة الله. مرحبا مرة ثانية. الحقيقة الآن يعني فرصة إنه معنا سعادة نائب المحافظ للمواصفات والجودة المهندس فوزي حكيم، وحيقوم بتسليم الدروع للأخوة المحاضرين، فلذلك هذه فرصة أيضا الالتقاء مع سعادته، فليتفضل. Okay, هنادي بالأسماء. I'll call the names, and so please, Dr. Richard Sechi. This way, please. Okay. الأستاذ الدكتور عبد العزيز نغيمش. الأستاذ الدكتور عبد الرحمن الحزيمي. المهندس رضوان حميد. الحقيقة ما عندي ما أدري الأستاذ رامي أو المهندس رامي الشطرات موجود؟ تفضل. الأستاذ رامي اشتراط لك نيابة عنه. نعم، نيابة عن الأستاذ رامي. ما أعرف من اليوني بيتون في أحد؟ اوكي، يبدو اذا المتحدث السادس لم يكن موجود الان. شكرا. Yeah, I guess now we can resume the discussion lecture. Yeah.
Okay, that was very nice. Thank you. Shukran. Still practicing. So the reason I show this here, because this is the way I think about a construction project, and each construction project looks similar to this, is I'm just a concrete supplier down here. I'm just this person. But imagine this person knows about EPDs, or this person does, or this, or here. Imagine how information travels inside of this diagram. Imagine the amount of information that each person or group may or may not know about these. That's our challenge. So, this room right here, full of all of these people that have chosen to attend, participate in this conference, you are now going to leave here and know about environmental product declarations. You're going to know the name. Imagine this person here, or this person gets asked by the owner who's flying on a plane home from Riyadh back to Dallas, and they're sitting on the Lufthansa plane and they read in an article about how important green building and sustainable design is. And then they come home and they tear that article out and they hand it to you and they say, go find out about this. I want my next project to be this. I say that as a joke. That happened exactly to me. My boss did that. He tore a page out of a newspaper, out of a magazine from an airplane and handed it to me and said, we want to build our next concrete plant like this. Gave that to me. Okay. So, this is the complication we face. This is the challenge that we face as a design, as a building, as a material supply community on how to respond to that, because everybody in here has a different level. Now imagine you're here and you know more than the people above you in the chain. What do you do with that information and knowledge? How do you communicate that? Now, not just on that project. Now, it's great that we can all sit in here and we can talk and we can discuss as professionals and we can communicate. But now imagine you're in the heat of battle in that project. It's moving at project pace, and there's bidding going on, and there's salespeople involved, and there's all these people who want these things at the regular pace that they want. The other thing is, regarding that pace, has anybody noticed in your community where you work that the pace of construction has slowed down? That anybody wants to move slower anymore when it comes to building things? We want to go faster, which means the communication has to be faster, which means the knowledge level has to be faster. This is the challenge that we have when it comes to sustainability, because we're not only faced with faster paces of construction, we're faced with faster knowledge that's out there. Remember how I told you 10 years ago we didn't think this way? In the history of concrete, we don't think that fast. Remember the slump test that was shown to you? When was the slump test created? On the slide. 1913 by a gentleman by the name of Chapman. 1913. That test is 100 years old. And 10 years ago, I told you we didn't think about concrete having an impact on energy. That's lightning fast in the pace of acceptance in the engineering and concrete community. That's how fast this is moving. The pace of construction is moving faster. The pace of knowledge needed is moving faster. And our whole ability to grasp some of these things is passing us by. In fact, I'll make the argument for you that the gap between those that are gaining knowledge and participating, and those that are choosing not to, is not getting closer. I'll make an argument for you that it's getting bigger. Because before some of you were in this room today, did any of you, those of you that have heard about it for the first time, yesterday you didn't know about environmental product declarations and their importance and their value? How many people are not in this room that haven't heard that yet and will not hear that? Okay, so when's this going to show up? First, highly competitive marketplaces. The first place it showed up in the United States, San Francisco, California. San Francisco, California, a highly competitive marketplace, but you know what also distinguished them between any of the other marketplaces around the country? They were the most environmentally sensitive marketplace in the U.S. They were the most environmentally aware marketplace in the U.S. Everything from what they do with coffee cups and how they dispose of those to how they buy and sell concrete. And so what happened there was one company said, we want to be more competitive. We want to distinguish ourselves from our competitors and show that we are more environmentally aware than our competitors. Within 9 months, another competitor in the same market had to respond. From a competitive standpoint, would you rather have your fate dictated to you by your own business choices or by your competitors' choices? Not only did they control the market and lead the market with that, they also got their competitor to do what they wanted them to do. That's a tremendous advantage in a marketplace. Now, as a business person, I would much rather be making my own choices than have them made for me. Now, who started asking for it first? You know who asked for the EPDs first on the job? Which job did it first? It was a government entity. Why was it a government entity first? One, they were the most visible from a community standpoint because it involved the community's tax dollars. And the other thing was, they were one of the only groups who could afford to do it the first time around because it was community tax dollars that wound up supporting it. The second thing we've started to see them crop up is for high-profile commercial jobs, big, tall buildings. But we've also seen small buildings do it too. A very small boutique hotel, a very small boutique set of condominiums or residences where they're trying to attract a certain clientele that knew about environmentalism, environmental impact, and environmental choices. And those people were going to spend money, but they were going to spend the money in the places that had the same values they did when it came to the environment. Okay. I finished up a little bit early here. I was supposed to go to 2:30, but I knew that there might be some questions here, so I was trying to time that appropriately. And again, having our honored guest here also helped a little bit. So, any questions on this before I turn it back over? Questions, please. Sorry.
About the polluted industry in USA. For example, cement factory, everybody knows that it's polluted. I heard that you are not producing cement. You are importing clinker. Is it correct?
Okay, so his question was on cement mills. So first, I would take issue with your fact that cement mills are polluting. Cement mills don't pollute. Cement mills have emissions. And then those people, someone can say that those emissions are polluting. I would say that those are the byproduct of having to produce cement. I don't make a judgment as to whether or not they're polluting. They just produce emissions. We were just having this conversation in the back that 1 ton of cement is responsible for producing 0.9 or 1 ton of CO2. Yes, that is a fact. Is that a pollution? Some people may classify this. That's just a byproduct of producing cement. Want less CO2, produce less cement. Now, his question was, are we importing clinker as well as producing? Absolutely we are, and it depends on which part of the country you're in. Right now, I have a big issue where I'm operating in the state of Texas, one state in the whole U.S. We produce more concrete in that state of Texas than the number 2 and number 3 states combined. Somebody with a calculator could probably do the math for me, but right now we're approaching the production of 50 million cubic yards of concrete in one state. That's one state. I've done upwards of 3 million yards a year with the company. So, are we importing clinker into that part of the country? Yes, we are.
From where? From where, Yobli?
Oh, from where? Turkey, Mexico, China, Egypt, Korea.
Third world, in general, third world.
Colombia. And it's just coming into the U.S. Now, I will tell you from a global perspective is to watch what happens in China. Because China, I believe it was in 2004, 2005, was not only the world's largest producer of cement, they were the world's largest consumer, which it was happening simultaneously, which was unheard of from a global cement standpoint. There's a lot of issues there. One of the things I was, again, speaking in a side conversation with other people was, there are 3 things that I know to be true: death, taxes, and concrete consumption tracks in a linear fashion with population. I'm going to have to figure out a single word for that yet, but I haven't. My point to that is that you can give me a population density in almost any market, and I can tell you how much concrete, cement, or aggregates that market is going to consume. As population grows, so will cement consumption, so will concrete consumption, so will aggregate consumption. And the question is, what happens when the lines cross? That point right there is what we affectionately call the cement apocalypse, because we don't know what happens when demand outpaces our ability to supply it. Not from a standpoint of, oh, that's great, we'll just charge more money. It has nothing to do with that. It's what do we do when there is no more cement available to continue to supply the concrete demand? What do we do? In some markets, we don't have answers for that yet. In some places, that problem is showing up in 10 years. And we are not building new cement mills. And importing it is not the solution, because all the imports come in through the same place, through the same theoretical pipeline, which doesn't get any bigger. And just because I put it in an import terminal, now I have trucks I have to move. And I can't find trucks, and I can't find drivers. We have very real issues related to that. So, yes, sir.
What is not encouraging people to go for like sustainable material or something, especially those who are looking for LEED certification, is that the points that are given for the material and for it's very minimal, a couple of points only. So when we talk sometimes to the owner that if you use like supplementary cementitious material or something, then you are going to get 1 point for it.
Right.
He said, I don't care about it. I'm getting this already from the lightning, from the water consumption, from the green, from other things. So 1 point, I don't need it. So I don't know why they cannot increase the number of points for the material so the concrete can get more material, more points in LEED accreditation.
So his question was about LEED, Leadership, Environmental, Energy, and Design. Just when I started this conversation, I talked about how with green buildings, somebody would say, well, how green is green? We had to put a metric on that. We have evaluation systems. And the U.S. Green Building Council came up with LEED, and that's about 80% of the projects that are evaluated are done with that. There's a dozen more other systems that do evaluations. And his question was about, but if I use concrete, I only contribute a very small place to the total points, to the total metrics by which they evaluate the project. Before, we used to go in as a discrete material, and we used to say, hey, I'm replacing fly ash, and that was his comment of I just get 1 point with that. Now, the ready-mix companies in partnership with the contractors are going in and presenting a concrete solution package. It's not just mix design based. Here's the 15 points you will get from using concrete in these places on your job. The mix designs will contribute 2 points. If you swap out the asphalt paving for the concrete paving, you'll get 3 points for reflectivity and water management. If you do these curbs and gutters and retention basins out of this concrete, you'll pick up another 2 because of this. They're submitting a package now to maximize the points so we don't fall into the mistake that has happened, which where we'd said, I have 25% fly ash replacement or GGBFS, and I can get 1 point. Oh, no, 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 no. We have a concrete solution package. But you have to have a partner. Go back to my drawing up here, my partner with the subcontractor and the contractor to go in and do that. What I found in my experience in the last 10 years, the only successes that I have had in my ready-mix profession were because I made mistakes. I made a lot of mistakes to find those successes. And what happened was when our market that I was operating in said, does anybody here know about green building? I raised my hand and said, yeah, I do. And I went first. I went first in the marketplace. And as soon as I went first in the marketplace, when the next job came up, they said, hey, you know about green building, don't you? Could you come talk to our guys? Well, you bet I will. Of course I will come talk to your guys. Because you know who they didn't ask? Was anybody else. So I enjoyed an advantage, a commercial advantage in my marketplace for about 4 years. Nobody could touch me when it came to sustainability and green building. Now, what about now? Well, of course, and I'm glad that they can, because I'm looking at the next thing. There was a huge commercial opportunity to what we like to call the first mover advantage. I moved first. Now, there's another theory called the third move advantage. And some of y'all play chess in here. Move a piece, move a piece, move a piece, move a piece. What's the third move? Can you think 3 moves ahead? With green building, we actually have to be doing that. What is the third move? Make that move first. That's the move that we need to be making when it comes to green building and sustainable design. This is a challenge for us because we are a reactionary industry. Somebody pokes you, you poke them back. Not, how do I avoid poking in the first place? That's our industry. There is a definite commercial advantage here. Anyway, that's my time at 2:30. If I'm going to stick around, more questions? Okay. Well, Canada's included in the North American one. Mexico, I don't have an answer for. I don't know what Mexico's doing.
It is not included in your program. I mean the cooperation between you, especially and Canada, about the environment protection.
Yeah, let me talk to you here in a second.
Any protocol about this?
Yeah, I'll talk to you in a second. Anyway, thank you very much for SASO for having me in. It was a very much an honor to be invited and asked, so I appreciate that. I've had a wonderful time here in your country. I'll be here for another 2 days, and I look forward to that as well. Thank you very much for having me. Shukran.
Thank you, Dr. ريتشي. اوكي، حقيقة برضه وصلنا للختام، فنشكركم جميعا على الحضور والمشاركة ونعتذر إذا حصل منا قصور، وفي نفس الوقت نتمنى التواصل المستمر معاكم، وحنزعجكم بالإيميل وتزعجونا وما في مانع، ترى عادي جدا. يعني هذه ختام هذه الورشة، وإن شاء الله تكونوا يعني أي تعليقات أي ملاحظات حابة ترسلوها بالإيميل أبدا، يعني نفس الإيميل اللي كان عليه التسجيل، لا ترددوا في أي شيء يكون على بالكم، وإحنا إن شاء الله حنرسل لكم أيضا الأشياء اللي في بالنا. القضية خلونا التواصل من خلال الإيميل. والسلام عليكم ورحمة الله وبركاته. نفس الدوسيات راسنا فوق. لا الدوسيات ما تقدر تصدر بدون ما تكون شكل المنهج. كلام عام ما عملنا شيء، لازم نعمل شيء بشكل منهج. لا لا المجتمعين ما تنجح. لا لا تحول إلى حاجة مفترض حضرت شباب المتحدة ده ما هي اليوم موجودة وعدونا قضية تقنية هذه المادة
والله احنا ودنا شو اسمه اساس يعني